Guys, I'm eating my lunch because everything is on a time crunch here. So, yeah, just you know what? I'll put on a starting video here while we're waiting here. Here, you know what? I got something. I got something. You guys will appreciate this. Here. Give me 1 second. Starting soon. Here. Look at this footage. You'll like it.
Full thrust.
Discovery, go at throttle up.
And vehicles cleared the tower. Vehicles begun the pitch over program. Body rates look good. And PU's gone to closed loop. System response looks good. Now 20 seconds into flight. Atlas is now completing the pitch over maneuver. Body rates continue to look good. RD-180 is throttled down slightly to park.
Noodles, man.
Response looks good.
Noodle.
6 seconds into flight. Atlas 5 is now passing Mach 1.
You guys probably don't want to hear that, though.
RD-180 continue to look good in partial thrust mode. Seeing good chamber pressures on all SRBs. And at 49 seconds into flight, max Q, maximum dynamic pressure. RD-180 engine operating parameters continue to look good. SRB chamber pressures also look good. Now passing 1 minute into flight. RD-180 now throttling back up to full thrust as expected. Chamber pressures on the SRBs continue to look good. RD-180 engine operating parameters also look good. Now 1 minute, 23 seconds into flight, approximately 3 minutes now remaining in the boost phase of flight. And at this point in the flight, Atlas 5 now weighs just 1/2 of its liftoff weight. And see SRB chamber pressures tailing off now. And we have SRB burnout. 1 minute, 45 seconds into flight. RD-180 engine operating parameters continue to look good. And we have jettison of all 4 solid rocket boosters. Vehicle's gone to closed loop steering. Body rate responses look good. Just past 2 minutes into flight now. RD-180 throttling down slightly as expected. Engine operating parameters continue to look good. And 2 minutes now remaining in the boost phase of flight. Atlas 5 is now 50 miles in altitude, 78 miles downrange distance, traveling at 5,000 miles per hour. 2 minutes, 40 seconds in.
Those freedom units, 5,000 miles an hour. You hear that?
Good. Vehicle body rates look
Yes.
good throughout boost phase. And the Centaur reaction control system is now pressurizing to flight levels. System response looks good. Coming up on 3 minutes into flight. RD-180 now throttling to maintain a constant 2.5 G acceleration limit, seeing good response on the RD-180.
How many kilofeet is that? 5,000 miles an hour? 25.
Body rates continue to look good throughout boost phase.
25,000 kilofeet, I think. Sounds simple.
Now passing 3 minutes, 20 seconds into flight. Approximately 1 minute now remaining until BECO. And we have good indication of payload fairing jettison and CFLR deck jettison. Vehicle's now throttled back up slightly. Engine response continues to look good.
Dude, oh man.
RD-180 now throttling to maintain a constant 4.6 G acceleration.
I will have this ramen done. This ramen will be finished before the end of this video.
And we have boost phase down. Passing 4 minutes into flight. Vehicle systems all continue to operate nominally throughout boost phase. Body rates continue to look good. RD-180 engine operating parameters continue to look good as it maintains that acceleration limit. And we have good indication of stage separation. We have ignition and full thrust on the RL-10. Chamber pressure looks good. Body rates look good. Centaur's gone to closed loop steering. Body rates continue to look good. Now 5 minutes into flight. RL10 chamber pressure continues to look good. Body rates look good. This first burn of today's mission will last approximately 6 minutes, 18 seconds. Now passing 5 minutes, 20 seconds into flight. Centaur is now 115 miles in altitude, 600 miles downrange distance, traveling at 13,000 miles per hour.
And now, guys, I've made it to the part where you drink the ramen juice. You know what I'm talking about.
Centaur PU's gone to closed loop control.
Oh, that stinks.
System response
The
looks
PU.
good.
We gotta drink the ramen juice. You know what I'm talking about, right?
Now passing 6 minutes into flight, approximately 5 minutes now remaining in the burn. Body rates continue to look good throughout the burn.
Milk was a bad choice.
And we have begun to see the RCS thruster firings during the burn as expected for thermal conditioning.
Ugh. That was good.
And passing 6 minutes, 30 seconds into flight, Centaur is now 130 miles in altitude, 890
Yes,
miles
Ben.
downrange distance, traveling at 14,700 miles per hour.
Yeah, and they didn't show the PLF jettison, which is a shame, but, I mean, not the PLF, the payload separation, because it was classified. It was classified, man. How are you guys doing? Enjoy your hour break? You ever drink hot ramen or have hot ramen so fast you start sweating? Because that's me right now. Yeah, classified. Oh. Hey, Tweets, what's going on? Why would they say that, Thomas? Did you already talk about the landing of the Falcon 9 today? We watched it live, Journey. Yeah, we watched it live, dude. You're on your break from mowing the lawn. It's 92 in Orlando, and I'm just about to go outside and finish it up. Well, why do drugs when you could just mow the lawn? All right, let's load up Kerbal, shall we? Boy, drummer. You know what, Bobby? Wear a hat. God dang it, Bobby.
Do I look like I know what a JPEG is? I just want a picture of a goddamn hot dog. Hot dog. Hot dog. Hot dog. Hot dog. Do I look like I know what a JPEG?
Falcon 9 fell over? There was a tweet with an image of it laying on its side. Can you link me to said tweet? I haven't heard that. Link me up, Journey. How long has it been since you've had a bad case of diarrhea? Oh, it's been a pretty long time.
I just want a picture of a goddamn hot dog. JPEG, 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 JPEG. I look like I know what a JPEG is? I just
Let me
want
see,
a
Johnny.
picture of a goddamn hot dog.
That's Jason 3, damn it. What is this? You got jebaited, man. That's a launch from 2016. It's not even the right Falcon. Hey, Black Raptor, 88-month resub. Yeah, here, I will show. I will show. I will show. That's Jason 3, man. I remember watching that launch. Oh, hosted webcast. Man. JFed right there. Tom Perderio. Tom and Kate. Kate called this morning's launch. Interestingly enough. You know what? It's in the how not to land a rocket launch. Here. How not to land an orbital rocket booster. It's in there. Here, I will show. I will show. There you go. That was from a different camera angle. See, that camera was over there. See? That is... That's... That's hard. That's hard to look at. Yeah, I don't want this. I don't want this. You can see the camera that they filmed that from. It's over there. Actually, it should be over there somewhere. But yeah, that's Jason 3, dude. Yeah, the booster landed fine from what I understand, but also hot dog.
My name is Jeff. My name is Jeff.
Bruh.
My name's Jeff. What's up, Jeff? When was the last unoptimal landing? 2020. Wait, Thomas, which one was the booster that had the booster skirt fail? That was the last failure. You've been playing F1? This? .1059.6 on February 15th. Turns out I'm not good at Imola. It's a hard track, man. Imola is very, very difficult. It is very... Dude, That's what I like about that track. San Marino. Well, it was the San Marino GP once upon a time. Autodromo Enzo Edino Ferrari. It doesn't look difficult. This track does not look difficult at all. It seems pretty straightforward, actually. It is one of the hardest tracks to drive, straight up. These turns suck. Tosa isn't bad. Piratella, Acquiminerale, and Variante Alta are very, very, very difficult corners. It doesn't have Bassa in it, though. Mixed reviews. Pepe giggles. I want the manager. Yeah. Access 2021 manager is what I want. That would be sick, dude. Tamburello. Orbiter, external tank, SRB. Respect. Respect. Halo would have saved him. And I'm saying that as somebody that hates it. I think they look stupid. That was in 2021. Should have included the year. It was just February 5th, 150th. I don't know, guys. I always buy F1. How this goes with F1 is that I always end up buying it, right? Chat's like, oh, we'll watch you play, and then I play, and then no one watches. I mean... Oh yeah, no, Dingleberg, I'm not going to deny it and say that it should or shouldn't be there. I think it looks stupid. I still think it looks stupid. However, it absolutely should be there. You know? Dude... Zhao would not be alive. It's not the car sliding. It's the car flipping over and landing upside down on the Jersey barrier that would have done him in. But none of that happened because the halo. That's fine. I get it. It's totally cool. I still think it looks stupid. But I'm not saying it shouldn't be there. Don't get confused. Yeah, Dink, I'll go with that. I agree with you. It looks better on these cars because it's not retrofitted. It's designed into it, which definitely, you're absolutely right. It definitely does look better. But just picture in your mind how sick this car would look if it didn't have it. Just kind of look back at it for a second, and it's like, oh wow. Oh, I mean, look at the Mercedes. Just kind of cast it out of your mind for a second. Oh, that would look sick. But once again, I understand why it's there. I'm not saying it shouldn't be there. I'm saying it looks dumb. But you know what, man? I don't care. Leclerc would have gotten a face full of fuel tank in Spa a couple years ago if it wasn't for it. Alonso's fuel tank, he almost ate it, but the halo pushed it out of the way. I started watching F1 after 2018, so now every car just looks wrong. Well, they're lucky Zhao's and one of the drivers who sits high in the car. Yeah. I prefer the aero screen like what Indy uses. I'm with you on that one. Yeah. Anyway. So, I mean, fellas, I wouldn't be against playing F1. I really wouldn't. I wouldn't mind doing it. However, every time I do end up buying Formula One, it's always a waste. I buy the game, I go 3 or 4 races in, and the first couple of races, everyone's super into it, and then we start really getting into the championships, to the championship season, and then people are just like, yeah, I don't care anymore. The chat always ends up devolving into, oh, when are you playing Kerbal next? When are you playing Kerbal next? When I get questions like that in chat, I don't necessarily take them personally, but that's a pretty clear indicator that nobody gives a frick about the game that you're playing. I did full-length races at super high difficulty, Hellfish. Yeah, that's what chat wanted me to do. I failed miserably, but hey, I completed the Hanoi GP. I did it. Oh yeah, Roman would be done, Jeff. Yeah, Yeah, no, the Halo, I'm not saying get rid of it. I think it looks weird, but that's a sacrifice we're just gonna have to make. Is there a video of the big F1 crash last week? Yeah, here you go. So watch these two right here. Which switches does your keyboard have? I don't know. Oh! See this part, right? There. Oh, ho, ho, ho. That's a nasty one, man. Watch. Yep. Oh, Jesus Christ. Yeah, they're both okay. Zhao and Alex are all right, and that's, yeah. Okay. Yeah. I think it would be more entertaining to watch if you scaled the difficulty so you're close to pace with the AI leaders. Yeah. Yeah, Helvish, I kind of saw it. Yeah, he survived. Yep, Zhao's okay. That's what I mean. The Halo looks stupid, but also, yeah. 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 Yeah, that car is like fully upside down. Oh, man. Spring. Oof. Dude, right? It's like it vaulted off the Lenovo sign. But right there. See, if this car didn't have a halo, he'd still be fine. He'd still be fine. It's this next part right here where the catch fence yeets the car back towards the track, and watch here. Look at where the halo lands. Right on the tire barrier. Yeah, that's death without the halo. Right there, that's death. Yeah. That's death. That's no, not breathing. Pretty crazy, huh? Where's hot dog and chill? There we go.
Do I look like I know what a JPEG is?
The cars are well designed, dude. I used to think like, you know, oh, they're making it safer, they're ruining the sport, blah 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 blah. And it was kind of like that for a little while, but you know, with modern tech, you can make the races still good and you can be safe. They're not mutually exclusive. Just look at this season. I mean, look at that crash right there. That's a pretty damn good example. I mean, I have somebody who drives cars, who races cars for real. Tell me about it. Like you can do this. It can be safe and it can be fun. It's not like it has to be a death-defying stunt every race. That's how it used to be in the 70s. And a lot of people died. So, The Halo, they say the Halo can support a city bus. I believe it's titanium wrapped in carbon fiber. Yep. Oh, that sounds about right. Okay, so, hot dog and chill. Yeah, Dead Crew, I'm kind of with you on that one. Alright, so we have the launch plate for the MLV here. Kenny Brack. Ugh, Brack's crash was brutal. I remember that. I remember that, Quantum. That was that was a little while ago. I didn't remember it. I think that was before my time, if I'm thinking of the crash that I'm thinking of. That was bad. Dan Weldon's crash still stings, dude. That one still stings. The Halo has a peak maximum vertical load of 116 kilonewtons. That's a hell of a lot of force, dude. Good. I mean, good. Whatever, dude. I think it looks goofy. I'm not saying it shouldn't be there, you know? Like, no, it should be there. Oh, yeah. Yeah, deal with it. You know? Link perms? I got you. Link. You could also sub. Did you guys know that subbing to the channel is like literally money printer for me if you sub with Twitch Prime? I'm really not good at this, am I? Nope. Nope. No, Procyon, I haven't. COVID kind of screwed up my whole schedule, dude. I'm not good at doing that plugin thing.
Discovery, go at throttle up.
Thanks, Access. That's not what I said to do. Damn it! You clicked the wrong button. Instructions unclear. Thanks, man. Oh, damn. Alright, let's get to it. You just gotta practice. Gross. Alright, so we were working on the umbilical. We got the umbilical hopefully figured out. Oh god, you did it again. I'm practicing. Oh, did you know that you can sub to the stream if you get a good look at a T-bone by sticking your head up a butcher's butt? No. No. I tell you, Chad, I can get a good look at a butcher by sticking my head up there, but I'd rather take the bull's word. No. No. I can get a good look at a T-bone by sticking my head up a bull's butt, but I'd rather take the butcher's word for it. Yes. Yes. See? You're not a good seller, but that is better because I know exactly what I'm giving you money for. Yeah. The Google Street View car passed me today before I got my haircut. Yeah. So, Twitch Prime sub. Yeah, okay. Hot dog. Alright, so this is the pad that we were using. I want to see if I can adapt this plate right to the other pad. You can get a good look at a Prime sub by sticking my head up Jeff Bezos' butt, but I'd rather take chat's word for it. I need some. You know what? Subject change. We gotta work today. We gotta finish this pad, damn it. This is the work music. Great picture, Thomas. Saw that, caveman. Pretty awesome. You know what? I need more motivation here real quick. We must be sufficiently motivated. We must be sufficiently motivated. No. We have been given the scientific knowledge, the technical ability, and the materials to pursue the exploration of the universe. To ignore these great resources would be a corruption of a God-given ability.
10, 9.
It's time for motivation.
Sequence start.
Headphone users.
5.
Headphone users.
3, 2,
You've been warned.
1.
All engine running.
All engine running.
Yeah, I really appreciate what you're showing me right now. Yes, GSF, yeah, it will. Oh. Mama. Huh? Did... Shuttle next? Shuttle? Oh. I mean... if you want...
T-minus 5 minutes and counting.
Go for orbiter APU start. PLC, perform APU start.
RPP, PLP, and
SRO.
SRO, so you have a range clear launch.
And CDR.
CDR and entire crew is go.
Okay, Scooter, well, look, it's a great day to go fly. On behalf of the KSP Processing and Launch Team, I'd like to wish you, your crew, and the whole Hubble Space Telescope team a A great mission. Good luck, Godspeed, and we'll see you back here in about 11 days. Enjoy the ride, pal.
Nozzle checkup.
Oh.
SRBs, firing chain.
Hanger B, I'll look at that later.
Sound suppression water system armed. T-minus 10, 9, 8, 7, 6, 5, 4, 3,
More motivation? I got more. That part was gonna get loud. Oh man, dude, that shot, this one, the last shot, this one, the retro propulsion shot is amazing, but this shot, oh, that's so badass, man. Oh my god, every freaking time, dude. I've seen this shot a bajillion times. I don't care. That shot's amazing, man. And then the drop, dude, the drop. Feast your eyes upon the supersonic flamethrower. The eye, dude, the eye. Yes, I'm with you. I'm with you on that. This, I remember the first time we saw this. The first time they did a RTLS at night, or with the right lighting conditions, I stopped talking. I was like that. It was one of those times where I just said, oh, it looks like an eye. That's so goddamn cool. Yeah, just hold on. Are you motivated yet? One more, Thomas. What's this one? Falcon 9 overview. I remember this one.
3, 2, 1.
Oh.
Liftoff of the Falcon 9.
Vehicles pitching downrange.
That's nice.
Stage 1 prop is nominal. Stage 1 entry startup. Stage 1 is transonic.
Oh. Oh, oh.
Stage 1
oh.
startup.
Oh, there's that shot again.
Stage 1 landing leg deploying.
Falcon 9 has landed.
Guys, I'm pretty motivated. I'm pretty motivated. You know what? One more. Where's the cat jams? I know, Hip. It's so ridiculous. Oh, it's so kick-ass, man. Well, click. We'll be seeing that again soon. We'll be seeing this again soon. Very soon. Yeah, okay. The more I see them perfect landings with minimal error, the more I'm starting to believe the chopsticks thing first try. Roro, I don't know if they're gonna get it on the first try, but I see how it's possible. It's the momentum. I'm telling you, it's the momentum of the booster. Lateral momentum is what gets that, is the thing that's going to make that more precise. If you're coming straight down into the chopsticks, I firmly believe this. Straight down into the chopsticks, you're susceptible to a lot of different things. Wind, just imprecision, right? And the booster will be able to... Once the booster goes straight up and down, it's like balancing a pencil on your fingertip, right? By SpaceX's own admission. How do you solve that problem? You need to be more precise. You have a window of about this big to land a booster that's 22 stories tall. It needs to be about as precise to fit in between my hands, like one of the landing pegs, right? How do you do that? Momentum. Lateral momentum. I think that the booster, if these are the chopsticks, right? The booster's going to come in like this. It's going to come in sideways. Not like totally translate sideways Astra style. No. It's going to come down like this. And it's going to use that momentum to keep it straight so it goes right into the chopsticks. There's no secret by looking at the chopsticks. They're way longer than they need to be. You know that by how they lifted up Starship. When they lifted it up, it was like halfway into the chopsticks like this. There's a runway there. There's a nominal runway. That's the key. That's what makes that possible. That's the flex capacitor, man. Having the booster come down slightly sideways gives you way more momentum and you can be way more precise. Think about it. It's like landing a plane on a runway versus a helicopter. Landing a plane with a crosswind is way more precise than landing with a helicopter in a crosswind because the crosswind's going to blow you all over the place. The plane, just give it a little bit of rudder and crab that landing and it can be just as precise, right? Same idea. That's what they're doing. I'm pretty damn sure. Astra style. Got that little quip in there, huh? That's what they're going to do. I'm pretty damn sure they're going to use the lateral momentum of the booster to get it super precise. That's why the chopsticks are intentionally really long. Because it's going to land slightly sideways. You're going to come in a little bit to the side. I'm telling you. Do it in KSP. You will be more precise with your booster landings. I mean, the thing is, though, you try to land with lateral velocity, your booster's just going to tip over, right? But it does work. That absolutely does work. That's the reason those chines are on the sides of Super Heavy. So it can come in sideways. That's the whole point. I'm telling you, that thing is going to fly. It's going to fly like Freedom almost. Like the Freedom rocket that we had boost back and land. It's going to be like that. Maybe not landing sideways completely in at the chopsticks, but she's going to come down with a lot of sideways velocity. I'm pretty damn sure. You could be way more precise with that. How many Raptors would equal 5 F1 engines? So nuclear... Here, let me jump back over. We got to finish our launch plate. Speaking, our orbital launch mount. Nuclear Super Heavy has 33 engines in it. 33 engines makes... math time. So, 2,400 kilonewtons per, because every one of them is a Raptor 2, right? Times 33 gives you 79,200 kilonewtons of thrust. Saturn V F1 engines make 6,700 kilonewtons of thrust times 5. Super Heavy literally has double the thrust of a Saturn V at liftoff. We are talking insane numbers. Nope. Dude, that's not even close. That's double. That's like a Saturn V with... That is untitled spacecraft amounts of thrust. It's an old Kerbal joke if you get the reference. There's... Here, look at this comparison chart. Here. So, you have X-Core, Maston, XA-1, Air Force Research Laboratory, Pathfinder, MLAS, Orion AA-2. You have Minotaur. You have ATK Athena 2C, Taurus 1 and 2. So basically Antares. Taurus 2 is Antares. You have Falcon 9, Falcon Heavy, Atlas 5, Delta 4, the Space Shuttle, Saturn 5, Saturn Nova. There's SLS in the 70-ton and the 130-ton Block 2 configuration. And then there's Untitled Spacecraft. Kerbal. Untitled Spacecraft. Hey, Rocket Guy. Super Heavy has untitled spacecraft amount of thrust. It's ridiculous. Like, I personally believe that they're the reason why nuclear, the reason why they're going with so much thrust is reliability. You could literally have half of those Raptors blow up. Half of them fail completely, and it'll still make it into space. Cool fish. Space. Saki. You think an engine as powerful as the F1 will be made again, or is many smaller engines like Raptor Merlin a better option in all cases? Hand, do you want the engineer's answer, or do you want EJ's answer? You know what? I'll just give you both. So, Hand, do I think an engine like the F1 will ever be made again? Sure. Yeah, something like that could be made again. That's EJ's answer. Yeah, I'm sure there is an application for that somewhere. But that segues me right into the engineer's answer. They'll get made again if there is a need for them to get made again. If you need that much firepower in one rocket engine, then yes, they will absolutely get made again. Nobody has ever made a rocket engine that big, it's before nor after. The F1 is about as big as you can get for a Carolox design. It really does not get much bigger than that. You get bigger than that, you're getting into solid rocket boosters. Solid rocket boosters are way more scalable than a liquid rocket booster is. The reason is because, well, long story short, it goes back to chamber pressure. It goes back to combustion chamber pressure. With a liquid fuel engine, you're getting into flow rates that turbo pumps just can't do. And in many regards, that's why Raptor is such a genesis in design. Because with Raptor, the turbo pumps can spin as fast as an F1 engine's turbo pumps did back in the day. If probably faster, actually. So the F1 basically brute forces kerosene and liquid oxygen into that combustion chamber. It brute forces it. There's the turbo pump that is on the side of an F1 is more powerful than a 747. I will say that one more time. One turbo pump on an F1 engine can produce more thrust than a 747. That turbo pump, that power pack off of an F1 is more powerful than most rocket engines themselves. Even by today's standards. That's how ridiculous the F1 is. It's a really application-driven thing, guys. I think that even today, if we tried to build an all-liquid booster like the Saturn V, like that, I still don't think we would use F1s. They would cluster engines. Once again, the reason is because liquid fuel rocket engines do not scale. They don't scale very well because you can't feed the liquids fast enough. And the advantage that Raptor has, what makes Raptor so ridiculous, is that they are using hydrostatic bearings in the turbo pump. When the Raptor engines are on, the turbine assembly in the preburner is literally floating in oil. It's floating in liquid. When it's off, it's just kind of sitting there. But when it spins up, it submerges itself. The bearings are hydrostatic. So non-movable water. Or it's not water, it's a lubricant, it's some type of oil. Heck, they could even be using liquid methane. I don't even know. I know it's hydrostatic, and the entire turbine assembly being submerged in water basically, or being submerged in oil basically minimizes friction in the turbo pump, and that's what gets the full flow stage combustion cycle to work correctly. The fact that the turbo pumps can maintain 300 bar chamber pressure. Do you know what the preburner outlet pressure needs to be for the combustion chamber to be sustained 300 bar? Think about this for a second. With a liquid fuel rocket engine, anything that is south of the turbo pumps needs to be cascading down in pressure. Okay? So the turbo pumps make higher pressure. The pressure coming out of the turbo pumps, in this case the preburners on Raptor, the outlet pressure needs to be higher than your combustion chamber pressure. If it's not, you're going to go to blow something up inside of the combustion chamber, and it's going to go backwards. You're going to get liquid fuel flowing upstream, not downstream. This kills the rocket engine. This kills the rocket engine very badly. Yeah, you'll break something. Think about that for a second. Raptor has sustained 300 bar combustion chamber pressure. The outlet pressure for the preburners has to be at least 3 times that. I would wager a bet that it's like 600, 700, 800 bar to be absolutely sure. But I'll bet you it's somewhere up there. You know how fast the turbo pumps need to spin to be able to move liquid fuel and oxidizer that quickly? To make that kind of pressure in the preburner, to make that kind of pressure in the combustion chamber? We're talking incomprehensible amounts of spinning. Not even the slow-mo guys could catch this turbo pump working in slow motion. Not even close. It would still look like it's going fast. Human person, 36-month resub. So, Nuclear, long story short, dude, like, the Raptors are insane. That is the reason why Starship can exist. Without these things, this thing is just a water tower. It was kind of a figure of speech hip-hop, but I did watch the slow-mo guys with the 9mm, shooting the 9mm through things, and I think they got it down to like a million, yeah, that 1,000,000 feet per second. That was actually really cool, seeing the ballistics of that 9mm. That was really cool. I don't know if this applies to the coaxial swirl injectors, but for traditional impinging jets, the pressure at the injector elements needs to be at least 20% more than the chamber pressure. Rule of thumb for not blowing up. The reason why I estimate double is for reliability. Over-engineer it for reliability. And, just over-engineer your full flow stage combustion cycle. There ain't many, and I know this isn't necessarily correlative, but there ain't many engines that can fire a vacuum-optimized nozzle at sea level and not blow up. Raptor can easily do that. That tells me that they're trying to figure some scalability into Raptor. So, if I had to guess, I would guess that the pre-burner outlet pressure is way higher than the chamber pressure. That's just a guess, though. And that's just EJ being an armchair rocket scientist again. But it's a water tower with canards, so you know better. All right. Is there a physical limit to how fast the turbo pumps can spin? If the impeller is over the speed of sound, I would be very surprised. Speed of sound? What, speed of sound implies that you're moving air. You're moving through a gas fluid. I mean, maybe on the... Yeah, well, I suppose with the pre-burner... Elvis, that's getting a little bit beyond my comprehension. I'm not even kidding. I don't know. Yeah. I would imagine you would run into some problems on the turbine in the pre-burner. It's almost like this stuff is complicated. Yeah, how the hell... Yeah, how the heck do they... Pray, Rocket Guy, help me out. What happens if you have supersonic gases flowing through your pre-burner impeller or pre-burner turbine? Don't you want the gas to reach the local speed of sound at the throat? But we're talking about the pre-burners, Bauxy, not the engine. Cavitation. Rocket Guy, does that actually... Okay, idiot question time. EJ has a question now. Does that happen? That must happen. How do you get around that? If the pre-burner turbo pumps are spinning at 30,000 RPM with a hydrostatic bearing, how do they keep the gases subsonic to go over the turbine blade? Does it impinge at the pre-burner? That's my guess. That's how... I mean, if I was going to do this in La La Land, where EJ can design rocket engines, I would impinge it right before the turbine blade to slow it down like a ramp intake. But then again, you're going to screw your chamber pressure if you don't. But then again, if you impinge it, expand it through the turbine blade at subsonic, and then put it through a throat after the turbine blade on the pre-burner, then that would work too. That would keep the chamber pressure high. You'd go from expansion through the turbine at subsonic to recompression. But yeah, that sounds like something that'll blow up if you're not careful. Now I'm really freaking curious now. I was about to guess narrow the piping. Well, yeah, in gas impingement nuclear, yeah. Huh. It's a difficult problem, but solvable. Well, I mean, they solved it with hypersonics. You'd have to do a scramjet in the pre-burner. No, that wouldn't work. That wouldn't work. That wouldn't work. Scramjets don't have a turbine blade. Yeah, Record, that's fair. It is rocket science. Let me look at this thing. keep in mind this is a Raptor 1, so this is old. Look, fellas. So this is that's the methane. That's the methane preburner. Look at the methane preburner. It does get smaller. It impinges it. See that? It does. I mean, that one does not. To be fair, this one doesn't look like the main exhaust or the main output of the preburner. I'm pretty sure that's what that cast piece that has the writing on it is for. I think this is for combustion chamber film cooling and throat cooling. I think that's what that dump is for, because look, the dump from this is from the methane preburner. This dump pipe goes down, it impinges, it goes to a manifold in the nozzle for film cooling, and then it also has it has a union here that goes back up into a manifold that's in the combustion chamber. That's probably for throat cooling. Throat film cooling, because Elon said that Raptor is combustion chamber throat cooled, or combustion chamber film cooled, throat film cooled, and nozzle film cooled, which is ridiculous. They went for film cooling basically on the entirety of the rocket engine because of the high chamber pressure. Careful with what you're saying. ITAR is listening. I'm not saying anything that isn't public knowledge, Nuclear. I'm very, very, very careful about that. Film cooling is probably the elements in the jacket. That's the regenerative manifold. Yeah, look at they got tap offs. They got tap offs at the main preburner outlet like crazy. Look at all of them. There's two tap offs there. There's the dump right there. Dude, this is complicated. I mean, obviously it's freaking rocket science. Like, but when I sit here and I say that, oh my gosh, this is so complicated. This is so complicated. What I mean by that, fellas, it's like, obviously it is, yeah, no crap, EJ, of course it's complicated. But the interesting thing to me is that I've been studying this and following this for such a long time, dudes. Yeah, look, Prey. See what I'm talking about? I mean, keep in mind, we don't know if this could be misinformation. You have no idea. But it is NSF, so it's probably right. Could be wrong, could be right, who knows. I study the plumbing, like I know how this stuff works in theory. But going and actually looking at the damn hardware, it still boggles my mind how complex it actually is. Like that is, even Raptor 2, that's absurdly complicated. And Raptor 2 is so simplified. It's unbelievable. It's possible that the nozzle extension is a separate manifold from the chamber. A gimbal mount is beefy. Yeah. This thing. I mean, look at it. Raptor engines are big compared to people. You see the people standing in the back. They're big. They're pretty damn tall, right? That engine, this thing, that thing is a third of a Saturn V motor. And it's not very big compared to an F1. This thing could fit inside of an F1's nozzle. I'm pretty damn sure. So let's take a look. Oh, yeah. Okay, so there's a tap off up here. There's a tap off the methane turbo pump that's upstream of the preburner. And they stage the methane. They stage the liquid methane for cooling because liquid methane has a colder... methane at liquid temperature is way colder than liquid oxygen. So that's why they're using the methane on the regenerative cooling. So there's a tap out that goes in at the throat. Right there. Where's that other picture? That other picture was quite good. It was really easy to see it. So there's the tap out right there. That's at the turbo pump. That's out. That's the outlet. The outlet is going in at the throat right there. See? So this tap off I don't even know if it's called a tap. I wouldn't call that a tap off. That's just, I mean, yeah, it kind of is. It's a tap off of the turbo pump. I don't even know. That's probably not the right way to say that. Pray, what are you saying? For cavitation, you don't necessarily need an excessively high dynamic pressure. Mass flow rate is the golden number, as is the total chemical energy that reaches the injector. You can lower the dynamic pressure and increase static pressure to move the same mass in the same amount of time. You can lower the dynamic pressure and increase static pressure to move the same mass in the same amount of time. Yeah. Long story short, Venturis, right? It's not, I know it's way more complicated than that, but this is also a solution to cavitation. It's more difficult because cavitation is a local phenomenon that occurs because of the small pockets of fluid dropping its static pressure from the blades. CFD doesn't always predict it well. Unbelievable. Yeah, true. It literally, it's not that far off from a wastegate, dude. It really isn't. Except this isn't alleviating pressure. They're using that. They're taking some of the liquid methane pre-burner to regeneratively cool the nozzle. And it goes in right there, and then it goes up and down. It goes up and goes in this pipe, and then it goes down and also goes in here and comes back up into the pre-burner. And that's where they get the gaseous methane for the pre-burner. And then there should be a LOX injector in here somewhere. I think that's it right there. See this pipe? See the LOX injector? Dude, the pre-burner is upside down. I never really noticed that. Pray, you see that? The freaking pre-burner's upside down. What in the... who the frick thought of this? Who thinks of this? That's freaking nuts. Like... So, like, okay, the reason why I'm, like, weirded out from the pre-burner, right? Because if you look... Here, hold on. If you look at a turbojet, okay? So a turbojet is an axial compression combustion engine, right? So you have... The flow of air always goes from front to back, right? When I think turbo pumps, I think it works basically like this. Only substitute your compressor blades here for just a fluid impeller, right? So you'd have like, you have your impeller that's pumping the fuel around, right? And then you have a combustor in the center, and then that combustor is shooting at turbines, and then you get exhaust gas out the bottom. That's pretty much how a turbo pump on like a Merlin engine on Falcon 9 works. The fluid flow is all in the same direction, for the most part, right? Only the impeller shoots fuel this way towards the motor, right? And then you have a combustor, right? And then you have turbines that are turning your impellers that pump more fuel, right? It's basically a jet engine with a fuel pump attached to the front instead of a compressor, right? That's how it works for like an open cycle Carolox engine like a Merlin 1D. It's that simple. With the Raptor though, you have your impeller and you have a radial impeller, right? You have a radial impeller, kind of like a turbocharger on a car, but it's moving fluid, obviously. So you have a radial impeller that shoots liquid out the side, right? And that goes down through the pre-valve, right? They heat up the methane, so the methane expands because it's cooling the motor, and then it turns to gas, right? And then they hit it with liquid oxygen. And then it sprays up. It sprays up, and then there's a radial exhaust out of the turbine. Like a turbocharger on a car. You have a radial turbine inlet. Only it's going in reverse. On a car, the hot gases go in from the side, and then they go out the back. This is the reverse of that. They reverse that turbine impeller. So it's a jet engine, but it's backwards. The flow goes out this way, comes back, goes in the backside of the turbo pump in the pre-burner. The combustor's over here and the turbines are there, and then it goes out into the rocket engine from where the shaft is. That's who the frick thought of that? Oh yeah, let's just take a jet engine and let's just flip it around. I know what you're doing and I'm gonna let you finish. But I'm just gonna take a jet engine and just turn the components backwards. That's nuts. It It's a radial fluid impeller with a radial turbine. That's... See, like I said, man, I've been studying this stuff for years. Apparently not studying enough. That's just bizarre. I'm pretty sure the pre-burner is liquid, not liquid gas. Yeah, I guess. I suppose. I mean, this thing does say it's liquid methane, but that liquid methane is human person. The only thing that I'm really I'm looking at this, right? And it has to, there has to be some gases being formed here, because 300 bar chamber pressure, man, there's no way that the liquid methane stays liquid inside of these channels. There's no way. I really don't think that it would. I think it would turn into a gaseous, kind of misty almost. Right? Read Husel and Huang book. Rocket Guy, it's bananas. It's a backwards radial preburner. I never noticed it. I thought it just went down the entire time. You know, your fluids are all going in one direction. No. Your liquid fuel is coming in from the top, and your liquid oxygen is coming in from the bottom, and it's being ejected out in the center of the freaking turbo pump. How the hell how is that even possible? I mean, don't get me wrong. I see it. I know how it works. But that's ridiculous, dude. Look at the pressures. It's staying fluid. Yeah, I guess. 611 bar at the preburner. 860 Kelvin. Yeah, that's a little warm. Husel and Huang. PDF. Modern engineering for design of liquid propellant engines. I'd prefer to buy this. Is it something that I could buy? Why does it need to be that way? Modern engineering for design of liquid rocket propellants. 118 bucks. I will be buying that right now. Give me one moment. Yeah, I'd always buy it, Rocket Guy. It's better. I could just write it off, dude. It's not a problem. Cool. Done. Bree, I gotta write some stuff off. So, Wish, why does it need to be this way? My guess is that it's packaged this way to kind of keep the engine compact. That's my guess. I mean, SpaceX literally put the LOX preburner like right on top of the combustion chamber, which is, yeah, that's it's kind of crazy, man. I noticed that there really isn't a... Yeah, see, there's no outlet pipe from the preburner. See, that's what's crazy about this. The methane, it has to be for packaging, Wish. That's my guess. The methane preburner is a radial turbine. But the LOX preburner is an axial turbine, that's crazy to me, dude. But the LOX one's axial because it's built into the top of the combustion chamber. SpaceX simplified the plumbing as much as they could by taking this pipe right here, 342 bar 808K, which should be right here, and because the LOX pump should be over here, it should be basically a mirror image of this, right? They took it and they simplified it by getting rid of it and put the LOX turbopump in the preburner on top of the Raptor engine. They attached it directly to the top of the preburner, which is insane. That right there is super complicated. Just because you're going right into the swirl port injectors, which is, I mean, it simplifies it, but just because it's simple doesn't mean it was easy. It helps with compactness, mass, reduces losses from extra piping, and you can even mitigate some seal designs. I mean, Rocket Guy, yeah, this is one of those things that's actually, it's complicated to do this, but it simplifies a lot, but I'm surprised nobody's done this before, you know? That's really smart, combining it all together like that. That's crazy, dude. And fellas, the reason why the LOX one is right on top of the combustion chamber is because when you have a methane engine, right? When you have a methane engine, you're actually flowing way more. Look at the difference in flow rate on the liquid oxygen versus methane. Look at that. They're flowing 5 times as much liquid oxygen as they are methane. Crazy, right? It's not 5 times, it's close. It's actually 4 times, if you want to be really technical. It's a little bit under 4. It's crazy. Of course, I still love you, and a tug known as Scorpius have started the trip back for the Starlink 3-1 booster to the Starlink 3-1 booster recovery zone. Cool. I just noticed something. The pressure drops about 100 bar from methane turbopump to preburner inlet. That means it moves through the cooling channels at insane speed. That's what I'm saying. That a 200 bar depressurization human, how does it stay liquid? How does it stay liquid, man? That's a 210 bar. I mean, keep in mind, these are estimations. And this is all just guesswork by guys at NASA Spaceflight. They used these numbers to try and extrapolate this because I know that was given information from Elon. Unbelievable. What's the mass flow rate of this thing? Imagine this, but with liquid hydrogen. A full flow staged combustion cycle hydrolox engine. Now that would be complicated, man. I don't know why it'd be complicated, but I know it'd be more complicated. I don't know that much about liquid hydrogen, but I know that liquid hydrogen sucks. It sucks to work with. Unbelievable. That's ridiculous, dude. It's crazy to me. Absolutely nuts. Raptor was going to be hydrolox, and they switched. I think methane is the much better idea. Using liquid methane like that is a compromise. Liquid methane and liquid hydrogen, it's a compromise, guys. You're taking a compromise on efficiency because you're lugging around that carbon. Because liquid hydrogen is H2, liquid methane is CH4. And, okay, incoming chemistry, okay? So hydrogen H2 is very kind of, I'm not going to say it's unstable, right? But LH2 does not want to stay LH2. There is like a nominal 4 or 5 Kelvin window where hydrogen exists as a liquid. After that, it goes to like 1 Kelvin and becomes a solid for like a split second before you hit vacuum. You hit absolute zero. In which case, yeah, I don't know what hydrogen's going to do. And then basically from like 5 Kelvin all the way up, it's hydrogen wants to be gas, right? So because it's such a short window for hydrogen to exist as a liquid, those H2s, the H2 wants to become G, so it wants to turn to gas, right? So long story short, hydrogen, because there's only a small window, couple that with hydrogen H2 mass is very, very small. Hydrogen is a very small atom. It's very tiny. It goes everywhere. It's worse than sand. You know why? Because sand is coarse, rough, and it gets everywhere. Hydrogen gas, it's rough and it gets everywhere, and then it blows up. Okay? It'll go right to your thighs, and then you'll blow up. So hydrogen is it's the most efficient. You can get the best boom for your buck right there, so to speak, with hydrogen, but it's very complicated to work with. Methane, on the other hand, has that big carbon atom attached to it. So there's C, and then you have 4 H molecules attached to it. That carbon atom makes everything nice. It makes the hydrogen a little bit easier. It makes the propellants, it makes the hydrogen chill a little bit, to say like, kind of, simply, right? It makes the hydrogen not want to go everywhere and explode. The carbon keeps the hydrogen in check, so to speak. It makes it a little bit easier to handle. Now, you still have that carbon in there, so you're going to take an efficiency hit, but it's almost as good as hydrogen. Yeah, Da Vinci, it's absurd. Yeah, hydrogen by itself just goes everywhere. It's like sand. Methane has that carbon atom, and that carbon atom is kind of corralling the hydrogen and keeps it in line, so to speak. It's funny because it's not in a line. That's what a hydrocarbon is. That's what kerosene is. It's CH, 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 CH in a long chain. That's what oil is, basically, guys. It's hydrogen and carbon. H2 has only 2 electrons and no dipole, so there's very little intermolecular forces between H2 molecules, so it's almost always a gas. There you go, hand. Is hydrazine even worse? Leop, the funny thing is that in terms of rocket propellants, hydrazine is very simple. It's very easy to handle. Meaning that it won't boil off. It'll stay nice. It can withstand a bunch of different temperatures and still stay as a liquid. You could just leave it inside of something. It won't decay. Well, it will decay over time. It'll just stay as a liquid. It's a chemical, right? It'll just stay like that. The problem is that it's a good propellant for rocket engines, but it's a very bad propellant for humans. Yeah, that's the thing with hydrazine. It'll kill you if you inhale it. I mean, to be fair, hydrogen too. Heck, too much oxygen will kill you as well. Yeah, you don't want that. But yeah, hydrazine is actually really easy to handle. It's a really easy rocket propellant to work with. But just because it's an easy rocket propellant to work with doesn't mean that it's a good thing for humans to be around. Uranium is a great source of energy. You don't see me with a block of uranium on my desk, right? I'm sure in 1985, plutonium is available in every corner drugstore. But in 1955, I'm afraid it's a little hard to come by. Marty, I'm afraid you're stuck here. Stuck here? I can't be stuck here, Doc. I got a life in 1985. I got a girl. Is she pretty? Oh, Doc, she's beautiful. Anyway. Hydrazine is the devil's oxygen. Yeah. Only hydrazine issue is when something goes wrong. It goes really wrong. Yeah, that's fair. That's fair. Like, at that end, the oxidizer for hydrazine, nitrogen tetroxide, you want to get into icky stuff. NTO is icky. Icky, icky stuff. Get this. SpaceX had a problem with a nitrogen tetroxide system on one of their Dragon capsules one time. So, get this. Nitrogen tetroxide is such a potent oxidizer and it's so pesky to deal with. Nitrogen tetroxide combined with titanium and combusted under high pressure. They had a little drop of nitrogen tetroxide in one of their pressurization systems, and they back pressurized it, and the nitrogen tetroxide flowed through the system the wrong way, and it hit a titanium valve. And because most hypergolic reaction control systems, like the one the SpaceX was using, are pressurized. They're pressurized with helium. That's how they feed the propellants, right? They pressurized it with helium. That nitrogen tetroxide got stuck up against the backflow valve, which was made out of titanium, and it auto-combusted diesel engine style. Seriously, it auto-combusted and it used titanium as fuel. Spoiler alert, titanium can be used as solid propellant. SpaceX figured that out. Yeah. Aluminum actually can be used as great solid propellant as well. It actually is used as a stabilizer for solid propellants. Aluminum, metal. Yeah. Talk about solid propellant. Yeah, that actually happened. Nitrogen tetroxide, bad. Yeah, it's a pain in the butt to deal with. SpaceX had a problem with it. It blew up one of their Dragon capsules. On a test stand. Thank God it was during a test. But yeah, titanium can be... Nitrogen tetroxide under high pressure can combine with titanium and make a hybrid propellant system, a hybrid solid liquid propellant system. That's how icky NTO is. That it can make metal explode. Pretty crazy, right? Aluminum is used as a stabilizer for military explosives as well. That's right, Lord. Oh, it's a great stabilizer. It's a great stabilizer. It gives you a really nice uniform explosion. True story. All right, let's get into building this launch pad. All right, I'm sufficiently motivated for rocket science. Let's go. All right, so what I'm going to do here is I'm going to get Freedom's pad, and we're going to make a modified version of that for MLV. Trud, you're going to sleep? Oh. Alright, man. Good night. We need LV3 pad R9. LV3 1AR9. Bingo. So there's the pad. This is the pad that we were using for the Freedom rockets. Night shift, more money, and a foot in the door. I got you. Venting on the OLM at Starbase. Okay, Jonathan. Got it. Guys, I mean... Let me see. I'm almost thinking just... put this literally on top of Freedom's pad. Like, as messed up as that sounds, just put that on there. What the hell is, what's the worst that could happen? I should probably remake it. But then again, can you guys recall anything in recent memory with the Freedom pad that we had problems with? I'm pretty sure we worked out most of the kinks with the pad. Yeah, exactly, Pop. But keep it simple. This, I mean, I'm fairly confident we had all of that stuff figured out. There are some things that I want to change with this rocket, though. Now, the Freedom pad, the Freedom style pad had a mobile service tower, right? It had an MST. I don't want to do an MST. An MST in the gantry crane. So the Freedom pads had the gantry crane next to it, and then if we were going to do crew launches, right, we needed the mobile service tower. Where are you? Freedom was super great. Well, I took a lot of lessons from Freedom and incorporated them into this design, dude. This is basically a 375 version of Freedom 10 with landing legs. I'm not even kidding. Oh. You know what? Sometime in the future, I'm literally just going to take a couple weeks and I'm going to fix this. I don't know if we should use it for mission mode, but I'm fixing that stupid thing. We can do it with hybrid tech. That was one of the most glorious things I've ever designed, ever. And I'm really annoyed that it's an open book. It's unfinished. I don't like that. I really don't. Thermal protection systems, Prey. This project could have an application, dude, for re-entry systems on other planets, dude. Think about it. Think about the benefits of something like this. Eve, that thermal protection system is insane. It can withstand really, really high heating because it spreads the heat over the panels. The panels can flex heat very well. Oh, so freaking cool. I need to go back and look at Freedom's pad, though. See, hybrid tech will fix the pad problems. Actually, you know what? Give me a month. Give me a month with the SSTOs, and I could fix both of them. Like 100% working. Oh, there's the LV4 project. This project eventually morphed into the MLV. You could see that there's very clear indicators here. Tank design. With the MLV, we decided not to use SRBs. See, there's the mobile service tower. I don't want to do that. I want a fixed service structure. This idea is cool, but it's a lot of parts. A fixed service structure will be less parts, and yeah, we don't need to worry about moving this stupid thing. See, I have the gantry crane over here, and then the MST. I want to opt for a design that's more like this here. I'm thinking Slick 37 for the Saturn 1, or where are you? LC 34, like that. Those are Saturn. That's Saturn. Nice. Okay, that's enough of that. Where are ya? I have some pictures of it in here. There's Slick 34. There's more Slick 34. Beast mode. Like that. See? I want a fixed service structure like this with a crew access arm. We couldn't do this in previous versions. That's why I opted for a mobile service tower that could move around. The reason why is because of drift. The robotic parts drift because the crew access arm is hanging off of one pivot. But we don't have to worry about that anymore, now do we? No, I can make a crew access arm that works. That won't drift with hybrid tech. So, yeah, we could keep the part count down on the pad. What kind of fuel do you imagine that MLV would use if it were real? The rocket looks like it uses hydrogen, but it, I would say, in terms of, like, could be methane, could be liquid methane. It's not Keralox. These numbers don't really jive too well with kerosene, but it could be. These numbers are pretty damn low. So you have a very energetic propellant, but it's not very efficient. So that's more in line with like hypergalls or like Keralox or something. Pigzig. That's what that looks like to me. But I could be wrong. I mean, it's just me. I'm just an armchair rocket scientist. From the power that it's making for the size of the engine, it looks like kerosene, but these numbers are more, the specific impulse numbers are more in line with hypergall. So like UDMH and DNTO, or MMH and NTO, monomethylhydrazine nitrogen tetroxide, what we were just talking about. That's what those numbers are more in line with. I think it just uses mystery juice. If I was going to design MLV in real life, though, So I'm trying to think what that rocket would be if it was using real engines. It would definitely be a 5-meter core, so it'd be about the size of Vulcan or Delta IV, but it has 7 engines in it. You can't fit 7 RS-68s under one Delta core. You can't. They're too big. So it would have to be something smaller than an RS-68. I don't really think there's any engine like that. It would have to be like RD-191s. It would be like 7 RD-191s could probably fit under there. Oh, nice, Betty. There you go. Yeah, Prey, they would have to be like mini BE-4s. They would have to be like an RL-10 sized BE-4. What would you rather fight? One BE-4 sized RL-10 or 7 RL-10 sized BE-4s? Actually, the BE-3U that's on New Shepard. Yeah. So it would be Hydrolox. Can I? How much thrust does this thing make? The BE-3U makes 710 kilonewtons of thrust. 500 kilonewtons of thrust at sea level. How much does an RS-68 make? RS-68 makes 29. MLV is a Delta IV with BE-3Us underneath, with 7 BE-3Us. That would be the closest. That would be the closest one. These numbers are pretty much in line with the Skipper engine. In vacuum and at sea level. They're very close. They're not exact, but they're damn close. We would need a throttleable engine to land the first stage. And the BE-3U is highly throttleable because New Shepard. Holy frick, we made a boost back Delta IV. Yeah, that's what it would be. It's BE-3Us. Yeah, these numbers actually scale pretty damn close. They're not exact, but they're pretty close. Holy crap, would that work? Yeah, 7 BE-3Us in a Delta IV, attached to the bottom of a Delta IV CBC instead of the RS-68. 7 of them would be making 3,500 kilonewtons of thrust, right? Because they make 500 at sea level. 7 times 5 is 35. The RS-68, a single RS-68 is enough to move a Delta IV core up with a second stage on top. Because of the Delta IV single stick, right? Delta IV medium. So, yeah, that right there is enough to move that with an upper stage and a payload fairing. And the RS-68 at sea level makes 3,000. And then up in vacuum, it makes 3,100. It's a great engine for what it is. Great engine if you're using an expendable rocket vehicle. Or expendable launch vehicle. Yeah, that would work, dude. So, MLV has a 375 core in Kerbal, and Kerbal is about 60% of scale of real life. So in real life, it'd be a 5-meter core. It'd be a CBC. It would be a Delta IV CBC with 7 BE-3Us. 7 BE-3Us in the first stage, and then it would use a standardized core size. So instead of a DCSS, we'd have a smaller version of this with a common bulkhead. So basically Vulcan's second stage. But Vulcan's second stage with a single BE-3U on it. Which, yeah, that would be really... That'd be a really good little rocket, man. And if you put that in a heavy configuration, yeah, that could work. Sure, why not? I mean, obviously anything is possible, right? But those numbers actually line up a lot better than I thought they would. So you ask what MLV is using in real life? Well, the closest thing would be Hydrolox. And we did make it orange, so the Delta 4 CBC wouldn't have it. I wouldn't use an intertank though. Well, intertank would be good, but if we were using the rocket, it would be actually no, an intertank design would probably be the better way to do it. It's weird how much that lines up. That's very strange how much that actually goes together like that. But yeah, no, it definitely works. No, I don't want that. Here we go. All right, let's get to work. So I'm going to keep this pad in the background here, but I am going to, we'll scratch build it, but it'll be heavily based off of Freedom's pad. Like, we're going to use the same gantry crane, because I know that gantry crane works, and I don't really feel like re-engineering it. It took me like a month to get that thing right. I could, well, we could get it right with we could make it better with hybrid tech. We could make it so the crane doesn't really drift. But crane drifting is not that big of a deal. Am I using a new mic? No. Same microphone. Okay, we have to keep this simple. It has to stay simple. Simple. We want, with any of my designs, whenever I build a launch pad, I try to make sure that the only parts that are contacting the ground are parts that have insanely high impact tolerance. It's a really good way to safeguard against Kraken strikes, because Kraken strikes usually don't hit with 80 meters a second impact force when something bonks into the ground. That's why I-beams and girders, coupled with the monoprop tank. The monoprop tank, what's that thing? 50 ms impact. Yeah, so yeah, I designed high impact parts. They're the only parts that touch the ground. It helps prevent Kraken strikes. So I have a couple ideas about getting the gantry crane lined up, fellas. I'm thinking what would be the real right way to do this. We need to make room for the gantry crane needs to be, we have to make room for it, and the gantry crane has to move, right? The only other way to do this is to make a mobile launcher and make a fixed gantry crane that does not move, and then roll the pad to the launch position and then set it down and then dock it to the pad. Ugh, I don't want to do that. So to quickly go back to the BE3U thing, there's a big discrepancy on the thrust number. Per the engines page, it's 710 kilonewtons. Per the New Glenn page, it's 550. And per the user's guide, it's 530. If it's above 500, Thomas, at sea level, yeah, it'd work. We'd have a lot of leeway, actually. But interesting. How many tons is this pad supposed to hold? Leop, it can hold up some pretty heavy stuff. I designed it that way. Like the small rocket company has? Which one, Sun Temple? There's a bajillion of them. We need to do some research into pad design here. The one that went out the fence? Well, that's Astra. Astra has a horizontal integration, dude. I'm not sure if we should do horizontal integration, man. I really don't think that that's a good idea. We could do it. Inside Enterprise? We could, but should we? So part of my stakeholder expectations for the project is that it does not take more than 45 minutes to get the rocket fully ready to go. I'm talking empty pad to counting down T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1 in less than 45 minutes. Because I found that if integration takes any longer than that, it just gets boring. People do like seeing the rocket go together. But not if it's going to take 5 hours to put the stupid freaking thing together. Alright? Stakeholder expectation is 45 minutes. If it doesn't do it in 45 minutes, I don't care. It's not worth the time. Join me on Thursday, July 14th as I take you inside the Space Shuttle Enterprise. The interior of the shuttle is not open to the public, so don't miss the special opportunity. Cool. What's the fastest you ever did a Freedom 7 launch? 30 minutes, Bluegill? I'm just thinking about some things, fellas. Okay, here, I'll think out loud. So what happens if I just place this on top of this? What's the downside? I could just place that like that and use the gantry crane and we could put this rocket together. What's the downside? Well, the downside is that that's going to get cooked by the rocket engines, and it's also going to get in the way. These triangles will get in the way. So, can we get rid of the triangles? Yes. Can we get rid of the inner hoop? Yes. Can we get rid of Freedom's old launch pad infrastructure? Absolutely. Can I get rid of those triangles? Yes. Can we get rid of the batteries? Yes. Can we get rid of those? Yes. What does that leave? The SRBs are definitely going to get in the way. And that's the root part. That's definitely going to get in the way. So I can't just retrofit this. We have to take this whole thing apart. I can't just attach it to the top and be done with it. Alright, so we're going to have to not necessarily go with something scratch built, but I have to take this whole thing all apart and then put it back together here. Now, another problem that I'm thinking. This width, right? I'm just going to put a caliper. We're going to make a caliper here real quick. I'll use one of my patented Tessa rulers here. And we'll use it to make a caliper. So, the gantry crane cannot be wider than this, right here. From there to there. That's the width. It can't be wider than that. If it's wider than that, then, yeah, it won't fit. The gantry crane won't fit. It has huge rollers that run here on this track. These I-beams that are in straight lines here are tracks. And the gantry crane has panels that ride on the outside of the tracks, and it keeps everything aligned. My launch plate cannot get wider than this. If it gets wider than that, we're going to have a problem. The gantry crane won't be able to roll over the pad. My gantry crane rolls on landing gear. The landing gear deploy, and it raises the crane up, and then I can use a truck to push it back and forth. That's what works. And then the panels ride on the outside of this, kind of like a train, and it moves back and forth. Now the center one is for lining up payloads and rockets. That's going to need to change because we have a 375 rocket core here. So there's no way I'm using a 2.5 meter wide track with a 375 core and a 5 meter launch plate. So that's going to have to go wide, which means we have to make the gantry crane a little bit wider. Not necessarily an issue, but something we're going to have to take into account. Can we get rid of the launch pad altogether, Kappa? Is this a launch pad? Yes. Mm-hmm. Your transport vehicle still needs to fit underneath? Well, that's something to also think about, Ordon. Not necessarily. With Complex 34 and Saturn 1, it actually went together slightly different. The bridge crane. Hold on. Yeah, they did something like that. I mean, that's on a test stand at Marshall, but they had one crane pick up the back of the booster, and then the main crane pick up the front of the booster to get the thing vertical. This would be complicated to do in Kerbal, just because I have to dock crane to booster, and then booster to another crane, and then crane back to the ground. However, if this crane was part of the same launchpad craft file as this, we would only need to dock there. And if I undocked that first, which I always would because we're verticating the booster, interesting. I can make this work. As long as the crane and the bridge crane, the test stand, and the secondary crane as long as they're all part of the same craft file, I can do this. Yeah, we can make that work. Yeah, sure. There's the same test stand. Some shuttle pictures snuck in there. That's Complex 34 when it was brand new. Yeah, Leop, I'm trying to think about part count, dude. That's very important. Dude, grabbing the booster and having the truck slide under the pad as I pick it up with an A-frame on the back of the truck did work. That worked really well. So, I don't know, Ordon. My dad just flexed on me that he watched the Falcon launch and is walking around SLS. That's lame. Why would he... Yo, take me with you. I'm pretty ready for it, Devils. I don't know about you. Alright. Okay. Let's do this. I need this to be slightly higher up off the ground, because we're going to need a bigger integration vehicle, obviously. I need to change the track width here. How's pad work going? I'm just figuring, Bagel, I'm figuring out some integration problems here. It turns out that going from like this to a 375 rocket, you start running into a lot of problems. For a 1.8 and a 2.5 rocket, my spacing on the gantry crane was just fine. You could fit whatever in there. But now that I'm getting into a 375 rocket and potentially bigger... So, okay, guys, the reason... Now that I'm getting into a 375 rocket and potentially bigger than this, like, when we build the HLV, do we want the HLV to have a different pad? Do we want it to use the same pad? How big is that heavy launch vehicle? What is it? Is it a Saturn V? Is it SLS? Is it Neptune? Neptune will never work with any of this infrastructure if I tried to do something like that, right? It would... No, hell no. That wouldn't work at all. Because Neptune had an 8-meter... Or no, yeah, an 8-meter core. Because it was 2 375 tanks. It was 4 375 tanks in 4x symmetry, right? That's what the Neptune rocket was. It was basically a Saturn 1B that was the size of Super Heavy. Right? Like Saturn 1B's first stage, where that was a bunch of tanks just kind of super glued all together. Not super glued, they were bolted, but whatever, it doesn't matter. Do we build for that kind of our infrastructure? Do we build for that? Because remember, this is all designed to be integrated together. I want to be able to build the small boy, right? And then have what we learned with the small boy work with the big boy when we go to build it later. MLV and HLV are intertwined. They're conjoined at the hip, so to speak. Just like Saturn V and Saturn 1B. That's the idea. So, I mean, what did they do? The Apollo program started with Saturn 1 at Complex 34, and then they ended up finally going to, Complex 39, and then they retrofitted Complex 39 with the milk stool to be able to launch Saturn 1B and Saturn 5 off of the same pad. So what do we do? What do we do first? Do I build for the big boy rocket? Come to think of it, I've never seen that rocket that DART launched on. It's Freedom 7 is what it's called. Oh, that's the Saturn V video. Nice. That found its way in there. So do we build that? Do we build it to work like that? How big is the heavy launch vehicle? In your opinion, is it easier to build big and retrofit the small or other way around? My intuition says it is. Yeah. See, now we're running into another problem, though. The problem is with the Saturn 1B, it made way more sense to put it on a pedestal like this and have the integration building move to the rocket. When the engineers got around to building Saturn V, they tried to build it like this, but it didn't work. The reason why it didn't work is because building a building the size of the VAB, big enough to house the Saturn V, and making it move would be stupid, because Florida's soil, which is right next to something that's very watery, wouldn't have been able to handle the weight. So that's one of the reasons why they made Saturn V and its mobile launcher move with the crawler transporters and stuff. And then they opted for the clean pad design, mobile launchers, blah 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 blah. You know the story, right? They made the launch pad move, and they didn't make the building move because the VAB, there's no way you're making that thing move. That's 500 feet tall. You're talking about moving a 50-story skyscraper. There's no way. It was better to make this static and just build it up on terrain and then move the mobile launcher. That was literally easier. That was an easier solution. What you see right there, which is absurd to me, but it is. But then the issue of if we build it for the big rocket now, we essentially constrain the rocket to fit the already existing pad. Who knows what kind of problems that could cause much later down the line, see the N1 program. Blue, what do you think is the right solution here? Do I design HLV now? Honest question. Build it for purpose, like you said. Well, once again, MLV and HLV are designed to work with each other. Saturn 1B, Saturn 5. Ares 1, Ares 5. They're designed to work together. Okay? They're designed to work together for what I call MOOF. Maximum on-orbit flexibility. I can make Earth orbit rendezvous missions. We could build stuff in low Earth orbit, right? We could, or low Kerbin orbit. We could send it all in one shot on HLV if we really want to, Saturn 5 style. Or we could do stuff like Constellation. I'm building the architecture to be able to do whatever, because missions to Eve in the future are going to require a big transfer vehicle. But they don't necessarily require crew and lander and transfer vehicle to all launch in one shot. So in that regard, it could work kind of like Constellation, where all the crew launches on the small vehicle, which is also just a good vehicle in itself, and all the crazy stuff launches on the big vehicle, right? On the note of 39A, a buddy had a question the other day that I wasn't sure on. Where is the nitrogen, LN2 nitrogen tanks at 39A? Pneumatic systems are right there. Pneumatic and HVAC is built into the pads. I know, Creeper, because I've walked right there on 39B, where my mouse cursor is. I've seen them up close. The turbines inside of pad 39B are as big as a smart car. And there's a lot of them. They use it to pump air up the mobile launcher and into the rocket. Those aren't just fuel lines and stuff. There's HVAC lines everywhere. There's vents, ducting to keep the payloads cool, keep the rocket cool, keep the lines thermally conditioned. There's all kinds of stuff. Yeah, the pneumatic systems are right there. And then the HVAC systems are in this building right here. Hey, Alucard. Only if you are confident that your current idea of HLE is what you'll need in the future. Well, that gets kind of into the next phase here, Blue. What are we going to need to do everything that I just said? Remember, building for purpose. So what does our heavy launch vehicle look like? What does our Saturn V, what does our Ares 5 look like? And I think if we figure that one out, it'll help us with this question here. I don't want to finalize the pad structure and then later when we start getting the heavy launch vehicle figured out, right? Later when we get the heavy launch vehicle figured out, have to redesign the entire stupid pad. We could go with a mobile launcher. I could do an ML. An ML could work. Complicated as that might be, it could work. Ooh, we got a little bit of a pickle here. So let's write off the hard stuff. Or let's write off stuff that doesn't make sense. Horizontal integration between the two launch vehicles is pretty much off the table. Or it... Yeah. I'm gonna say that building a transporter erector for a large rocket like that, I'm not sure if I'm smart enough to do that and hit my 45-minute integration rule. I don't think that's gonna work. So horizontal, we're not doing that. Fixed pedestal pad, we don't have to worry about soil, right? So I could do a fixed pedestal. That would work. But we'd have to redesign the gantry crane. We'd have to redesign the pedestal. We'd have to redesign the fueling stuff. But we could use Freedom Derived stuff for all of that. And I know that would work. I know it would work. The MLV is crew rated, Ryan. I haven't designed a crew vehicle for it yet. That's one of the things that I want to get done before we go back into mission mode. I want to have the MLV, the HLV, their pads, and the crew vehicle, and the lander, however that may be, all figured out and designed before I go back into mission mode. Keep everything vertical all the time. SPMT stages around. Yeah. Now we have to build an SPM. Now we have to build an SPMT. Pray. How do we do that? Seriously, if you say rover wheels, you're out of your freaking mind. Rover wheels are sprung. They're sprung. That's a really stupid idea. It'll just bounce around. Just like everything else in KSP, it'll just bounce around, and then it'll eventually tip over and fall. I'm not doing that. Have you already designed the HLV? No, HLV has not been designed. Bandit, what's that? Interesting. Sid wanted to be a game developer. All this stuff is intertwined, dude. In some way, shape, or form. So, no horizontal integration. Do we really want to move this stuff around vertical all the time, Prey? I mean, it makes sense, but man, I didn't think we'd run into this pickle today. But then again, this is me dusting off the cobwebs for KSP. These are the projects that I like to do. I like solving these problems. It's fun. It's very, very, it's candy for my brain. I hope you guys enjoy this. Pulling a vertical rocket with a truck only makes sense if you can simplify the crane. I can simplify the crane. That's not an issue. All right. I think in order to really understand this question and understand the criteria for this question and answer it more, we need to kind of scrub together what the HLV is going to look like. What are we talking about here? I was always under the expectation that a rocket like Neptune would be more or less what we're looking for. Neptune was a reusable rocket that I used in past mission mode saves. It was a reusable rocket that I used in past mission mode saves that had a reusable, or it could have been reused. It had a first stage that could have been reused. I never did it though. If you guys want to see Project Neptune, it is one of the biggest rockets I've ever made. Scoby. Where are you? You ever go back to the shuttle pad? Remember the docking ports worked for some reason? It would need to be explored, Ryan. But yeah, this is Neptune. Neptune is 375 cores in 4x symmetry, and then I had Mark II rocket fuel fuselages going up the sides in the form of chimes. I could probably make this better. Well, I know I could make it better. Yeah, panel inner stage. Ugh. Now, Neptune's first stage can boost back and land. The thing is, it lands on pegs. It lands on these I-beam pegs. And that's it. I never got further than just recovering this after every reuse. It has 4, 16... 36 shuttle engines in the first stage. 36 shuttle engines. It costs $1.23 million to launch, and it can move 400 tons of payload inside of its 10-meter fairing. 200 tons payload capacity with reuse. The first stage does boost back, it does come back down, and it does land. It works exactly like Falcon 9, but
Discovery,
big.
go and throttle up.
Wait, is this the supersized version of the rocket? Yeah. This was my version. This was the heaviest launch vehicle I ever put into service. Not because I can't build bigger. I can build bigger. Triton is bigger than this, but I never used Triton because it didn't make sense. I don't need anything bigger than Triton, or bigger than Neptune. Neptune is a great rocket. Triton was something that I did for a very short week in like 2019, Shaw, because Yarg was like, I bet you can't. What's the biggest rocket you can make? Like, can you build bigger than Neptune? I bet you can't. So I ended up taking a break from whatever I was doing for like a week and building Triton. Triton is Neptune's bigger brother. Much bigger brother. Savage Bear. Triton uses 5-meter tanks instead of 375 in 4x symmetry. I did away with the Mark IIs going up the sides and just use 5-meter tanks instead. It's a 10-meter stage, 10-meter diameter stage, and it has that. That was just a test. That never worked. It doesn't launch, Gary. It doesn't work anymore. Something that they changed with the features broke it. It just blows up on the pad. Shame. Fueling Neptune manually would suck. Yeah, it would be terrible. I only worked on it for like a week, guys. Yeah, it was quick. I didn't work on it for very long. But yeah, Triton's beast. It's a big rocket. A very big rocket. There were no engines powerful enough to move a core like this, so I had to overclock these. These are 300% of rated. These put out so much thrust that the attachment joints in KSP, if I throttled this up too quickly, if we didn't sequence, like, I actually had to sequence ignition. If I didn't sequence the ignition and I just hit spacebar with the throttle at full, the thing just blows up. The loads get so ridiculous here with engines that make like, well, 300 times the thrust limit of that is, and those are Mastodon engines. So they make 4,000 kilonewtons of thrust for the most part, each one of them. That was the only way, overclocking was the only way to get those engines to work right, to get the thing to go up. So, if we have this thing, something like this, working in conjunction with the MLV, what the hell type of pad do we build for something like this? And how do we get it to work with MLV? I don't think I need something as big as Triton, guys. I really don't. Triton was absurd. I think this thing could move like 1,000 tons or something. It was so ridiculous. And it can boost back and land. This is an old version, though. I think Neptune might even be a little bit too big. Yeah, I know. Triton was insane. It is a ridiculous rocket. R4, I think, was the version that we got working. Yep, Triton R4, there it is. It doesn't work. Like I said, it doesn't work anymore, or else I would show you. Launching this thing is absurd. I'm pretty sure it just blows up. This is a super heavy launch vehicle. We need heavy launch vehicles. I agree. Well, my HLV is always intended to be a heavy launch vehicle by definition. 100 tons or something like that. That would make more sense. Because think about it, Blue. The Saturn 1B can move 25 tons into space. Saturn 5 can move 125 tons into space. See what I'm talking about? I want a similar correlation. My MLV can move about 20 tons into space. So whatever the HLV is, it needs to be able to put about 100 tons. I honestly don't think that means building a vehicle this big. I really don't. But let's see. Like I said, this thing, it used to work, and then I tried loading it a little while back, and putting it on the pad makes it blow up now. They changed something. Yeah, headphone users. Yep, I muted it before it blew the sound out. See what I mean? Yeah, it doesn't work. I don't want side boosters, Blue. I want my stuff to be reusable. My expectation is that at least the first stage on MLV and HLV, stakeholder expectation is that those cores are reusable. I wish this thing worked. Dude, seeing this thing go was absurd. It was ridiculous. But yeah, it doesn't work anymore. So, 100-ton payload capacity from the heavy launch vehicle. How big of a fairing are we talking about here? A 5-meter fairing? 5-meter fairing for 100 tons. We have a 375-meter fairing for... We have a 375 fairing for 18. So what does a big fairing look like? What does a big launch vehicle look like? I don't even know. Let's just, you know, I think this is a good question to ask. What does this look like? Are you going to land the first stage on the pad or have something to recover it? It's going to land next to the pad, Leop, not on the pad. I don't think I can do on the pad, man. I'm good at this game. I'm not that good at this game. Let me think. So Saturn V. Let me look at some stuff. The core diameter on a Saturn V was 10 meter, if I'm remembering right. Diameter 33 feet. It's 10 meter wide. So if we were going to make this rocket a true Kerbalized Saturn V, it would be 60% of 10 meters, which would be a 6 meter. It would be a 6 meter core diameter, right? 6 meter. Because Kerbal scale is usually about 60%. So that's 5 meters right there. What does a 6 meter core look like? Well, hang on. That's a 5 meter core. That's 6 meter diameter right there. Chief, how you doing? I'm not even thinking about the name, RJ. Yeah, I'm not even thinking about that right now. Much more pressing issues, my friend. That works, but there's huge tank overlap there. That also works, but there's also huge tank overlap there as well. So what is this untitled spacecraft? I just got a blank craft file, Rocket Guy. I ran into some stakeholder problems when I went to try and make the pad. Because I remembered that we're building 2 launch vehicles here. We have the heavy launch vehicle and the medium launch vehicle. I could just make MLV's pad right now, and I could make it based off of Freedom. But what happens when HLV starts flying? What happens when I need the heavy lift capability? What happens then? Do I redesign the pad? That'll put us back into development. I don't want to do that. Remember, the whole thing is designed to all be engineered all at once. 2 launch vehicles. And I think it would be prudent to make both of those launch vehicles use the same launch pad and have similar commodities, similar attachment systems, etc., like the Saturn V, right? Because that's what works. So I'm just looking into what does our heavy launch vehicle look like that conforms with our stakeholder expectations for this project, for Project Ares. What are our 5 meter tank parts? Those are all the 5M tank parts. That's $375. I don't want that. I'm not using tweak scale, Creeper. Yeah, we're not doing that. Wait a minute. If I set that does that hold fuel? No, it doesn't. That one does. That just is an adapter. Got it. Okay. And that one doesn't have those adapter things on it. Only this one does. Interesting. The Squall, we closed on the house. That's all done. We move in a month. Congrats on closing. Thanks, Evil Bit. Congrats. Thanks, man. So 1, 2, 3, 4, 5 are the 5-meter parts that we have, and then we have this, which I'm not using. I'm not using that. We're not making a Saturn V here. We're not hosting an intergalactic kegger down here. Are you kidding? It's not symmetrical. How the who made this? For real? It That's a thing. That is a thing. That's a thing that exists. Okay, good to know. That's not an older part, Tars. 5-meter parts were added more recently to the game, don't you think? So, I hate that all this raceway stuff is on the sides of these things, but I'm thinking a 5-meter core would probably be more or less what we're looking for. Okay. 5-meter, that's a good thing though. If a 5-meter core is what we're looking for, then yeah, we could just give it a bigger fairing. We could hammerhead the fairing like Falcon 9 and give it a 5-meter core with like a 7-meter fairing. And that would be very useful. Are you going to make a super heavy launch vehicle? I'm looking to do it, yeah. What was this? Hold on. What did I make this out of? That's a 5 meter. S4256, yeah.
Discovery, go at throttle up.
Hey, Raise My Pandas, what's up, man? 50-month resub. This is getting a little bit challenging, dudes. Have I ever made a 5-meter core launch vehicle ever? I don't think I've ever made something like that. That's what I'm thinking. I'm not looking at Starship being like, oh, I should use this. I'm wondering if I've ever made something like that. Have you seen this footage? No. That's cool, though. We'll look at that for Space News, dude. I think I built my Saturn. Jebstone 5. Jebstone 5 is it. That's the one. You're making a vehicle or GSE stuff? Long story. Just bear with me here. Yep. Yep. There it is. Okay. Yeah, Make, I don't really remember. The Jebstone would be the closest one. Jebstone 5 was basically a modern... It was a modernized Saturn V. It's what I would imagine a modern Saturn V would look like. Yeah, that's basically it. That's the only 5-meter I've ever made. So, you know what I'm gonna do? Let's go new, don't save. This is the Project Ares Space HLV concept. Okay, let me look at some stuff here. I'm gonna build out a concept here, and guys, the reason why I'm building out HLV, I know the title of the stream says we're building pads in GSE. What I did was we went to start building the pad for the medium launch vehicle, right? We went to start building it, and then I realized that, do I want to build 2 pads? Do I make one pad specialized for the medium launch vehicle and one pad specialized for the heavy launch vehicle? Are we going to have 2 pads? That the part count would get awfully high. It would probably be better if I had one pad that can service 2 vehicles, like Slick 41 can launch Atlas or Vulcan, or like 39A can launch Falcon 9 or Falcon Heavy, or 39B could do SLS or Omega if Omega ever decided to happen. It didn't. But what do we do? What concept fits the best? And in order to put that puzzle together and figure out which one of those concepts is the best, I need a heavy launch vehicle, at least a concept of what I'm looking for. I need something. So I'm gonna build out something here and let's see where it takes us. Two pads would be a lot of parts, but how would you do 1 pad 2 rockets? I don't have the answer to that, dude. We made this pad able to launch Freedom 7 and Freedom 10. It works with just an adapter. You could just launch an adapter. Heck, I even made it so it could use both. Yeah, that was it. Now, something like the SSTO, that needed 2 different launch pads. The SSTO needed a small launch pad that was 2 kilometers away from the main pad, and then the main pad was used for the big SSTO. That's how we did it, right? That worked. It works. Took a second to drive any payload out to the other pad, but it does work. If we have to do that, that's fine, but yeah, I mean, we could do that. That works. It could work that way if we really wanted it to.
Discovery, go at throttle up.
See if Black, 32-month resub. Thanks, man. Anesthesis, yeah, it'd probably be better to use. I was about to say it'd probably be better to use 1 pad for everything, but consider this, dude. What do we do if down the road I have a bunch of extra first stages for HLV and MLV sitting next to each other? The MLV's first stage is 400 par. Oh, crap. Oh no. What are we gonna do? I mean, what is the freaking HLV stage gonna look like? That stage is gonna be like 600 parts. Well, actually no, it'd probably be about the same. But even if I have 1 HLV core stage sitting at the pad area and we go to launch MLV, that's still 400 parts just lingering in the background with like 1,000 part frick. Off-site storage? Where? It's not gonna work. That's the we ran into a big problem here. That's not gonna work. Damn. Rocket Guy, I'm running into part count problems. It's a long stakeholder expectation thing, dude. You might have to make 1 pad at the desert and 1 pad at KSC. RJ, we could do that. So, okay, off-site storage, Shaw, means we'd have to move the vehicle horizontally. There's no way we can move the vehicle vertically off of the hexagonal plates at KSC, right? There's no way we can do that. And how much of that 45-minute launch time is going to be me driving back and forth between the storage site? We've played this game before. That doesn't really work too well. You know, that doesn't work too well. Crap. 2 pads, the desert for heavy launch vehicle, KSC for the medium launch vehicle, is the desert on the equator. It's 6 degrees south latitude. So, Rocket Guy, I have a little bit of a stakeholder problem. The stakeholder problem is that the stakeholder problem is that I want my first stages to be reusable on both vehicles. I want them to boost back and I want them to land. The problem with that is that if we do that, right, and I have both of the vehicles operating off of pad 1 at KSC, right, there could be a potential scenario where I have like 3 or 4 HLV core stages and like 4 or 5 MLV core stages just sitting there, right? And the MLV core stage with its hybrid tech landing legs is 400 parts. You know, you have 3 of them there. You're already at 1,200 parts in scene in physics simulation because they have to... My expectation is that they land near the damn pad, right? So that's way too many parts to have sitting next to the launch pad during integration operations because it violates my 45-minute integration rule, right? So that's not going to work. Hey, Smoke Doubloon, what's going on? Oh, I got myself into a right fine pickle here. Well, requirements are iterated upon with new information, so if a reasonable solution cannot be found that incorporates all requirements, then requirements must be changed. Yeah, I know what you mean. This might be stupid and not fix any of the problems, but have you thought about sea launching? I mean, Brian, I could make a sea launch pad. Sure. I could put one of these pads out to sea. Yeah, no problem. If we do that, though, how do I get the rocket back to it? And now the answer there is to land. You land it back on the... Make it big and flat and land the booster back on it. How many times can I reliably do that? How many times can we reliably get that done? Am I good enough to land that thing on it every freaking time? I don't know, dude. There's the Cove launch site. Oh, I forgot about that place. But now I have to tote a core out there. You know, how do we get payload out there? Do we just spawn payload at the core site? Do we move it from KSC? What if we have a reusable crew vehicle? You know? What about having one launch from the pad and one from the runway? Keep both at KSC, but still separate pads. The runway spawner is within 2.5 kilometers of the VAB spawner, Creeper, and yeah, bad for performance. 10% of the time, all the time. That's how many. Fly it. Remember, we have to buy the Cove in mission mode.
Discovery, go at throttle up.
Hey, Tron, 67-month resub. I see one solution that may fit your requirements, depending on what other requirements you're designing to. But what if we just recover landed boosters? Of course, we don't take the easy way out and just recover. Only recover after full safing of the vehicle. So you still check all the boxes, without fully reusing the boosters, but you still reuse in spirit. Keeps part count low, shows reusability, incorporates requirements. I mean, Rocket Guy, I'll be 100% honest with you. If I was doing it that way, just hitting the recover button on the vehicle, there's really no point in building a pad. You might as well just hit the launch button. So I might as well just go back. I honestly, if that was the case, if we just hitting the launch button, I'd use the shuttle. I wouldn't even bother with this. I would just go back to using Collins. I don't necessarily want to do that. The whole point of mission mode is the challenge. You know, you got to think of the end-to-end solution, right? Of getting that booster back to the pad, or safing it, or moving it back to the pad, etc., right? Like, that is a viable. I don't see it that way, but fair. Is it possible to launch like Sea Dragon, or do you actually need a pad in the ocean? I could Sea Dragon it, sure. Right, you would still be doing all that, just recovering a fully de-integrated booster. Then when ready, put that de-integrated craft file on the pad. I mean, some Rocket Guy, at that point, my question is, if we could fully de-integrate the booster, why don't I just drive it out of render range? Right? You just drive it out of render range. I can make a storage facility. I've done that before. Right? Like, that'll work. Where does the requirement for an MLV and HLV come from? Will one be sufficient? I need a heavy lift launch vehicle to move bigger payloads into space to build bigger vehicles that go further into space, Wenwu. And I need a small vehicle for launching smaller cargo, and crew, basically. Because you said how that would violate pad integration time requirement. Yeah. With all of that driving. Ooh. Rocket Guy, I have an idea. It's a stupid idea. But I'm pretty quickly thinking that this could get out of hand real quick, in which case we're stuck with like crazy part count integrations. Even if I do recover and bring them back out and recover and bring the stuff back out, right? It's still like, how do I keep track of what I have out and what I don't? Like, you know, like say I have 4 booster cores stored, that's like $1 million, right? In mission mode. What if I misappropriate that fund? You know, like what if I have $1 million left over and I forget that $1 million in my mission mode coffers are for stored boosters, you know what I mean? It's just really hard to keep track of all that. I'd need an accountant at that point for mission mode. Dude, when does the 45-minute integration timer begin? Basically when I start to put the rocket together, Wenwu. Oh, if it's when I start to put the rocket together, I suppose the drive time is not going to be that big of a deal. Guys, we also know that there's another flat spot. I could put 2 pads at KSC. We've done it with the SSTO program. There's another flat spot. There's another really, really, like, perfectly flat piece of terrain that's good enough to put a pad on and integrate on, because we did it with the small SSTO. That's actually over here. Right there. It is out of render range. It is flat, and I could put MLV over there if I really wanted to. Is that requirement specified? I never specified it up to now, Rocket Guy. This is what I mean. Like, MLV and everything has pretty much been trade studies. I need 45-minute integration time, and that was just plainly stated. So if it's 45-minute integration time, dude, let me ask you, would you count taking the rocket out of storage as part of the integration? I would, because why else would we move the rocket around? Right? Like, why else would we be moving it around if it's not to put back on the pad and use again? I would count the drive. That would, yeah, you'd have to. How long is the driving? It takes 5 minutes to drive, less than 5 minutes to drive from like here to there. We towed SSTOs and fueled SSTOs back and forth, no problem. But that made sense with the SSTOs because the SSTO doesn't take long to integrate. You dock one thing, turn it upright, and then you're good to go, right? But didn't that have issues hauling back and forth? I've worked out most of those problems, Denny, going back and forth and cracking strikes. I've figured that one out. That one's pretty solved. I'm just trying to differentiate between driving and integration. Crawlers? Perhaps the requirement just needs to be resolved and the 45-minute time requirement changed. Then we have some slack. We could put it to an hour.
Go at throttle up.
I could bump it up to an hour, Rocket Guy. That would make the drive time worth it, you know? Oh, nice, Dipsy. There you go. Hey, Ismic. 20-month resub. Fellas, I got a nutty idea. No, that's just me looking to engineer more things. I shouldn't do that. I think an extra 15 minutes isn't all that much. I think that's a good idea. Okay.
Discovery, go at throttle.
Panta! 46-month resub. Thank you. 46 months of mid-tier gaming content, but top-tier space news. Thanks. Is the runway part of the KSC render area? Yeah. Everything here is in render range of the pad. How's the launch vehicle coming along? It's okay, Ismic. I'm running into a little bit of a problem here. Building out the one launch vehicle is great. And the MLV is great. It's pretty much ready to go. I started designing the pad, and then I figured out, well, I need MLV and HLV. MLV is just a medium-duty launch vehicle. In order to get the true scope, like, of maximum on-orbit, like, flexibility, I'm going to need a bigger rocket. I'm going to need them to work in conjunction, like Saturn 1B and Saturn 5, right? And if I want them to work in conjunction like this, do I make them launch off of one pad? If I do that, if I make them both launch off of one pad, well, that could... And my boosters are reusable because they come down and land, and there are a lot of parts because they're designed to be reused, right? Well, that's good. All those boosters just sitting there are going to stack up very quickly. So, do we drive the boosters away? I think that would probably be the right solution. But if we drive them away, where do we put them? Is the drive time of moving the boosters back and forth, does that get incorporated into the integration time? Well, yeah, absolutely. Of course it does. Suggestion, make all first stages able to fly back to the runway, and then your issue is where you launch from if you have multiple pads. Suppose. We've had an anomaly? Why not land them away and drive them to the pad for integration? Because the idea is that I could land the booster right next to the pad and put it right back on the pad to launch it again. Rapid reuse. Which feeds into my integration time. Sounds like a bunch of band-aids. Yeah, Melee, that's what I'm saying, dude. Yeah, it's going to be... Damn it. This is what I was trying to avoid by trying to think about the whole scope of the project. I'd have to make a hangar, Ismic. And I've done that before. I can make a hangar and I can store stuff in it. That's really no problem. We did it with Condor. Worked just fine. See, part of me wants to sit here and solve this problem. But the other part of me is like, just get MLV running. And getting MLV running and figuring out the best ways to reintegrate that could lead to better answers down the road. You know? Hey Johnny, what's going on? That could lead to just trying to get MLV working in mission mode could lead us to better answers for HLV down the road, but we could also engineer ourselves into a dead end. Not sure if this would work, both vehicles off the same pad. Yeah, docking ports, maybe. Maybe. Why use the adapter plate, RJ? Like, what's the, how, yeah, no, hold on. Hold on a second, bud. I'm thinking. What is the HLV and MLV launch kit it's going to look like? MLV would probably see more work than HLV would, just like more Saturn 1Bs launched than Saturn 5s. If you're going to be drive around rocker, a crawler would be cool to see. Yes. Yeah, you're not wrong. Damn. And then you can land the MLVs near the pad and HLV away from it since it has less use, maybe? It's possible. No. I had an idea in my head, and you guys started asking questions, and I lost it. All right. Nah, that wouldn't work. No, that's not a good idea. Damn. Crap. Universal adapter. Oh, yeah, sure. I mean, son, I'm not sure what problem that solves, but okay. So, I mean, okay, yeah, universal adapter. So both vehicles use one pad. How does that solve our storing the boosters problem? So, okay, I've narrowed it down to two things. Here's what we could do. Excuse me. Let's back out for a second. Here's what we could do. So, alright, I'm going to play two options here off the table, and you guys tell me if this is a good idea or not. I'm honestly not sure. We could have one pad, and that one pad can launch HLV or MLV, right? And then we could just store the boosters somewhere else. Or we'd want to land the boosters out here. We definitely would want to do that. So I could just make one pad, we could launch it off the side just like we did, no problem, boosters good to go. Okay, so that, and then we could land the boosters over here or next to the flagpole, or we could land them right here or right here, and then we'd have a vehicle to be able to take them back to the pad. We could put them on there. I could make a universal adapter for the pad. We could figure that out. That would work. I know I could get that to work correctly. We could just use the crane to configure the pad. No problem. The other idea I had was basically making the launch plates part of the recovery vehicle. So that ring that you just saw with the hold down points on it, I could basically put that on some type of transport vehicle, and that transport vehicle, when the booster lands, could drive underneath it, reattach it, and then it could drive it back over to the pad. I could pick it up off the transport vehicle and just put it back down. Have the adapter plate ride with the vehicle during recovery. That could work. And that would make it so I never have to adapt the pad. I just put the rocket on the pad, and both of the adapters for MLV and HLV use the same attachment system on the pad. Boom. There you go. If I was going to do that, though, why not build mobile launchers? Mobile launchers would work. They would be a more specialized thing, and then I could have them interface both to the same thing. Now, if I was going to do that, if we were going to do that, we run into the same problem. Where am I storing the mobile launchers? How do I get the rockets back onto the mobile launcher? How do we do that? SpaceX solves that problem with integration, with horizontal integration. They could just pick the booster up and whoop, right back on, no problem. Would a crane on the back of truck work? Work for what? I have a crazy idea. What if I built a VAB in front of the VAB right here? What if we did that? It would be a VAB with two high bays. So basically, one high bay would be right here for HLV, and the other one would be right there for MLV. Now, hear me out. Okay? Hear me out. That would be a lot of parts. Not as much as you might think if I build it like the gantry crane. Wouldn't be too bad. But it could end up being a lot of parts. Have a bay right here for the heavy launch vehicle, bay right here for the medium launch vehicle, and make a crane, just like the VAB, that can go back and forth, right? And make it so I can pick up the boosters. You could feed the boosters from the side, transfer aisle style. Transfer aisle style. Pick the booster up, put it in the bay, and then that crane could go all the way over here. Or we could just make two gantry cranes right next to each other and make it all one vehicle. And we could pick up HLV parts, pick up MLV parts, put them next to each other on their mobile launchers, which would be on here. And then I could roll the mobile launchers down each one of these here. Or we could move them so they ride in a track, basically between these two things. Or we could roll them down the side. It doesn't matter. And then I could put the pad right here. Basically right there. So if they're rolling down here, they can roll into position, right? We'll make them all, we could put them on landing gear just like we did with the gantry crane. That seems to work. Or I could make one type of crawler that basically works, it doesn't need guide rails and it could work like this. People have done that in the past. People have used my gantry cranes and used these humps in the ground right there to make a track. That does work. And then we could put the pad right here, and then the mobile launcher will roll down here, and we have the fueling umbilicals here. Problem with that is, well, these parts are out of physics range. They're more than 200 meters away. They are not out of render range. That would make it so I could accidentally switch back and forth. And when you switch back and forth, you reload the physics between these two things, and that makes things more likely to drift. It makes more things susceptible to Kraken strikes, and there are risks. There are risks involved with doing that. But that solves most of our problems because we're out of render range, or we're out of physics range, but we're not out of render range. So that'll solve a lot of performance issues. Rendering stuff is not very processor intensive. It's graphics card intensive. But the problem is that you can switch stuff. You can switch to stuff back and forth. That's out of physics range, that's in render range, you'll be able to switch to it because the game understands that it's there. And if you do, you unload and reload the physics real quick of the thing that you just switched from. That could have disadvantages. Sounds like a lot of extra work for reuse. I mean, yeah, that usually comes with the territory, Melee. It'd be really cool, but that's an insane amount of complexity, no? You got a better solution? For the clarity, the problem is scooping up used boosters. No, not necessarily, DeForo. I had a thought when we went to go to build the pad today. If I build the pad out here that's designed for my medium duty launch vehicle, right? And say we launch and land, everything's good. The pad wouldn't be too many parts. The medium duty vehicle could take it. It could launch. We could land the boosters right here. I could pick them up, put them right back on the pad. Now, what happens if we need a heavy duty launch vehicle? Where does the medium duty launch vehicle go? Where does the reused first stage go? Do I just put it over there? That's it. You run into that same render range problem. Do I make one pad that can support both vehicles? How do we do that? See, now I'm running into some roadblocks here. I'm running into some requirement roadblocks. And yeah, running into some damn requirement roadblocks. I'm not 100% sure. I'm not 100% sure how we'd solve this problem. Do this on the runway. What would be the difference, Lord Socks? Why the runway still is... The runway isn't long enough to be render range, physics range. Out of render and physics range. It's not more than 2.5 kilometers. Guys, physics range is 2,500 meters. Render range is 2,500 meters. Physics range is 200. The only other solution that I can really think is just move all the medium-duty launch vehicle facilities out here. And then just have those boosters land over here, have them stored over here, and have them work completely separate from the heavy-duty stuff over here. That's the only other thing I can think of. Or we launch MLV out of the desert. If we launch MLV out of the desert, we never have to worry about it. But the desert, you're going to get a performance hit. You're going to take a performance hit because the desert is... You're going to take a performance hit because the desert is 6 degrees south latitude. You could do a launch pad that supports both in a storage area away from the pad, flat area out of render range. Yeah, someone. Well, that's the idea that a lot of other people had before you popped in. But do our requirements change now? Think about it. I wanted a 45-minute integration time because I don't want to spend 5 hours of stream putting a rocket together. Clearly, chat does not want to see that either, right? So, throughout my travels with the Freedom rocket, etc., right? I noticed that about an hour is like good enough integration time. I can put the rocket together, I can explain the mission, I can tell people what we're gonna do. It builds up a good amount of hype, and then we can launch, right? In a very similar way how I would start up a stream before launch coverage for like a Falcon 9 starts. You ideally want to start your stream like an hour before the launch happens, right? So you could build up some fun, right? You explain the mission, you can say what's going on, etc. I would argue these are all questions for when you need an HLV. Right now you need to get something flying so you don't get stuck in design paralysis. God, that's absolutely 100% false. No, nope, bad idea. No, if I wait till I need the HLV, a month of analysis now would take 6 months of analysis down the road. No, that's absolutely false. You know how I know? We just got done with a program like that, and it ended up taking a really long time because I didn't design the vehicles at the same time. Bad idea. Bad. Go read systems engineering. Get dunce cap for you. No, it's not a good idea. Any analysis that we put down, we get done right now, dude. If I chose not to do it now and we ended up doing it later, would be like 3 times the amount of analysis and testing later. You don't want to do that. You want to set you want to set out your stakeholder goals and expectations and requirements sooner rather than later. The sooner you do that, the better. Bad engineer, no cookie. See what I'm talking about, dude? You don't want to do that way. That's a logic trap that you can get stuck in. The space shuttle is a good example of let's design it now because we have to get back to launching and then we'll figure out the missions later. That didn't work. That didn't work well at all. Just joined. What's happening? Don't get too technical. I'm new to this. Oh gosh, Fonzie. I'm coming up with stakeholder design requirements and expectations for my new space program that I'm going to implement with my career mission save. The quick and easy way of describing what I'm doing, dude, is I'm in a little bit of a logic puzzle. When I build my rockets, I build the pad for the rocket as well. I don't just put a rocket out on the pad, hit the spacebar, and go. I've been playing Kerbal for almost 10 years. That doesn't do anything for me. Oh, put the rocket out. Hey, we're good. I like putting the rocket out on the pad, driving the trucks out, fueling the pad, fueling the rocket, sneezing, and then like going through the countdown and using cow controllers in Kerbal and using the basic computers that you get with the robotics to be able to launch the thing and have like a reusable pad. And then like if my first stage comes back down and lands like Falcon 9, I like taking that and putting it back on the pad and launching it again. I like doing stuff like that. It's fun for me. So, long story short, what I'm trying to figure out right now is a way to make a pad that works for a medium-duty launch vehicle and a heavy-duty launch vehicle and not be completely screwed by part count. Because in Kerbal, the more parts that you have in the scene, right, in the render, the more your computer's going to suffer with physics simulation. So I'm trying to figure out a good way to get around that. It's a little bit of a logic puzzle with systems engineering. Bless you. Thank you. Dang, sounds fun. Gotcha. Thanks for the explanation. Yeah, no problem, dude. It gets complicated, man. The reason why I had Saturn V up on the screen is because the Saturn V is a good example of one pad that can launch 2 rockets. 39B and 39A, well, 39A was this way. That's Constellation. 39B and 39A could launch Saturn Vs or Saturn 1Bs or unmanned Saturn Vs. You could do a lot with them. But they used a mobile launcher design. That's why I was looking at this. They put the whole rocket, they put the whole dang thing on a huge launch pad, and then they lift up the pad inside of the VAB and they bring the thing, they bring it out. They bring it out to the launch pad that way. Hello. What's the video in the middle of your background? Starship. That's SN10 landing. What's this link? Can we not Space News link right now, fellas? I'm kind of... That's pretty cool. But yeah, I really want to figure this stuff out. Yeah, see, they moved the whole damn thing out there, out to the pad. I just got my blood drawn, so I'm not running at 100% right now, but transporting the booster from storage 2.5 kilometers away to the pad, especially if it's stored with the launcher adapter plate, shouldn't increase the time by much. Yeah, pretty much. Yeah, that might... Trailers and stuff would be a good idea. That would be a good way to do it. Save it for later. I didn't want to derail the stream. I don't know if you answered or not. What's the middle video in your background? That's SN10 landing. Starship SN10. It was from a test flight from last year. Yeah, that up there. It's pretty sweet. It's called the flip and burn maneuver. It's how Starship lands. If you would you rather work at NASA or rather at SpaceX? I'll work either one. I don't really care. Either one. SpaceX would be fun, but I wouldn't say no to NASA either. Maybe I'm thinking under a false assumption. Does the HLV exist? I have not engineered it yet. What about a static pad that is a place for transporters with specific plates, one for MLV and one for the HLV to slide in, less laggy driving? What about JPL? What about it? JPL is part of NASA. I'm confused. What are we talking about here? You confused me. So why move the assembled rocket to the launch pad? Move the launch pad to the rocket with cargo and second stage and assemble it on site and launch. That's what we did with Freedom, Orion. Yeah, that's what we did with the Freedom rocket. If I'm super interested in rockets and spaceflight, have you ever tried to apply for at NASA or SpaceX? No, I haven't. I'm not an engineer, dude. I'm a 3D artist by trade. I don't do engineering. I do it for fun content for KSP, so we can have some cool problems to solve and show how the boys and girls that really work in the industry actually do it. That's my whole meal ticket, dude. I mean, yeah, no, that's what I do. Excuse me. Yeah. I lost my train of thought again. Dang it. Showing the boosters seems like the right move, dudes. Would you rather work in rocket design, manufacture, or mission control pads? I do like the mission side of things, but I really like designing all the infrastructure, how everything goes together, the rocket and everything. It's like building a really big train set, but more fun. Hey, Nazalik, what's going on? Okay, so to use this Saturn analogy, Saturn wanted a separate pad to be able to launch while 39A was still under development and construction. That's all I'm suggesting. Yeah, I know what you're saying. Yeah, Guy, I understand that, but you know, Saturn 1 and Saturn 5 were both designed at the same time, right? They were designed in conjunction with each other. And that's why Saturn 1B was just able to end up launching from 39B right out of the gates. Like, you notice that they just went from launching from 37B, 37A, well, never launched from 37A, 34, and they just, oh, Skylab missions from 39B now. See what I'm talking about? They were designed at the same time. I'm designing right now. We're not building. There's no real building in KSP because I hit the launch button and it builds it for me, right? So, we're in the design phase. Neither of my launch vehicles are past CDR right now in the design phase. This is tough, man. It's rocket science, dude. That's an awesome picture. What if you launch your vehicle from the water and add C in front of the name? Yeah. Damn. The storage facility, I think, is the best option, guys. Storage area. Either that or make the MLV operate off of a separate pad. See, now I'm just going back to what I'm just build mobile launchers that would work. But the problem is, how are we going to get the mobile launcher up onto the pad? How would we do that? That's not going to work. What is your best guess on our next space mission? I don't know, dude. The faster I solve this damn problem. What does it require to be able to launch from the same platform? Is it the height, the weight? No, I can make adapters. I can make an adapter piece, Fonzie, and have both of them launch from the same pad. I've done it in the past with different rockets. That's not an issue. The main problem that I'm running into is, so what happens if I have my big launch vehicle and my small launch vehicle, and I'm not using my big launch vehicle? Where does the big launch vehicle go? Does it sit next to the pad? Because if it does, if it sits next to the pad in like a stowed configuration, that's just eating away at my performance, and that screws with my integration time. I want to be able to put one of these boosters, like go from an empty pad to a pad, like a rocket on the pad, ready to go with payload in like an hour. Because I have to remember, not remember, you don't know this. The save that I play, when I have mission mode up here, see that over there? When I have that up, that save, if I'm playing my mission mode save, the rule is that you have to put the rockets together. I have to assemble the rockets. I don't assemble stuff inside of the VAB. I use the VAB and the SPH to manufacture stages for me, and I put the stages outside and we reuse the stages, and etc., etc. Yeah, that's what I like doing. Yeah, so It's the storage that's going to screw me on performance. Personally, I think having a secondary location like the Cove or the desert is a good idea. Less complexity, although I don't know KSP anywhere near as much as you do. I can use the desert. We can do that. I haven't built anything out there since Condor way back in the day. Then we gotta do fuel mining, right? I believe that was the rules, Papa Bear, yeah. Jebward's, the desert, per my mission mode rules, does not have fuel production capability. You'd have to put a fuel refining facility out there. From an engineering standpoint, removing complexity is always going to be a more preferable solution because you're removing a single point of failure. Yeah, of course. Okay. Man, I got myself into a proper problem. Jebwords it is then. I don't need to use Jebwords, guys. There's a flat area where we launched the small SSTO from that works just fine. That area would be really good for doing this, actually. This is you at work, face-bombing, trying to make stuff work. I am at work right now, NG. I'm at work right now. This is a hard problem to solve, but I make these problems on purpose. I make this more difficult. I self-admittedly, you know, I could just put the rocket on the pad and hit the space bar and go, and we'd be fine. But I don't like doing that. What do you learn from that? You don't learn from anything. You guys don't learn anything from it. I don't learn anything from it. You know, this is a STEM stream. We try to learn stuff while we're playing games. That's the fun part. Hydrate time? Yeah. The only issue I have with that is recovering and redeploying it requires towing it back to the default pad and then towing it back to the... what if I just land next to the pad? My gut's telling me just finish the stupid pad, but also at the same time I know that that's not a good idea. But then again, if we're using two separate pads, then that really doesn't matter now, does it? I'm more talking about the actual pad. We'd likely have to recover and redeploy the pad every so often to deal with drift, if I recall correctly. If it's an SSTO pad, that has the transporter erector, but we don't have that. No, you don't need to do that as much, dude. Right, I want to see the VAB idea. Yeah, me too, man. Did someone suggest something that is going to prolong the GSE build? No. Go back in the VOD if you're wondering what problem I'm trying to solve. Yeah, two separate pads. Two separate pads is the way to do it. That's the way to get this done correctly. Okay, so now I need to design a pad that's easily movable. I mean, you're right about the gantry crane. The gantry crane will drift over time, but it won't be too bad. The gantry crane does drift, but if I can get like 10 launches out of a gantry crane, refurbishing it and putting it back out there is not that big of a deal. That doesn't take very long. So the crawler is out. I don't know. I'm not sure. I've engineered myself into a corner here. Have you ever had those moments where you get on KSP and you just freeze for a moment because you don't know what to build? There's so much to do. I actually have the opposite problem of that, Doubloon. I never don't know what I want to build. I know exactly what I want to build. I get hung up on how I'm going to build it because some of the problems that I propose for us here on the stream are very, very difficult problems to solve. These would be difficult problems to solve even with real rockets, like, let alone in KSP. How far away is the desert pad? Might be fun to build a tanker plane and fly out there versus mining. About an hour with a subsonic plane, Chris. It'd be about an hour. I have a plane that could move fuel out there. That's not a problem. I'd rather just mine on site, though. That's more... That would be smarter to do that way. So you're going to make 2 launch sites or 2 interchangeable pads. 2 launch pads would probably be a better solution, Ryan. As much as I wanted to see a mobile launcher... Yeah, that's the right move. Now, you know what? Here's the thing. I'm going to try to make them work off of 1 pad. Now, we don't know how bad that performance is going to be. It might suck. It might not. If I try to make them work off of 1 pad, and we make the adapter plates, right? We should just go. I'll build it, and we'll try to make it so I can make 1 pad that can adapt to 2 different types of rockets, right? If we do that, right? If we do that, and it turns out that the performance is actually a problem, okay, fine. I take the pad and I modify one so it can only launch MLV, and I modify the exact same pad with the exact same adapter so it can only launch HLV, and then we just build another pad at the other site. I'm going to try to make them... Or I just put the same damn craft file out there and we can launch MLV from out there and HLV from out there. It's like 39A and 39B. That's the right move. That's the right move. That's what we should do. I'll make it so I'll make the pad so we can launch either one. We do have to come up with the design for HLV, or at least a rough estimate of what it's going to look like, etc., right? But yeah, that's going to work just fine. I'll make the pad launch both rockets. If it ends up being a performance concern, just put another pad out at the other launch site. There's a flat area that's out of render range of the launch site. I could just duplicate the pad and put it out there. And then I have 2 pads that can launch 2 different types of rockets, and we could configure each one for however the heck we want. That's the right move. No, horizontal integration is completely off the table, Chief. That's a waste of time. It's not horizontal integration, even with hybrid tech, dude. I still would rather do this way. Quick question. Why would having a dual rocket pad design be more performance intensive? Couldn't you just make it to work with the diameter of HLE and then have an adapter to hold MLV? It's not the pad, it's the performance of storing the boosters within range of the pad to be able to put them together quickly. That's always been the problem. It's not that I can't build the pad. I guess I didn't make that clear. Because I didn't make that one clear enough. Okay. Well, that's the idea. It's not that I can't build the adapter. The adapter's easy. Easy peasy. We've done that many times. You're looking at the adapter right there. We could make one mobile launcher for MLV and one for HLV, so that would be essentially be two pads. You just lower them onto the stands. With what vehicle, Ryan? One we make /yes. Time is it? Oh, almost time for space news. Yeah. Yeah. And if the heavy launcher is going to use... If HLV is going to use a 5-meter core, that's a 5-meter circle. I could just take these hold down points and just shift them out. It's really not that big of a deal. But the ring wouldn't be... we need to make a bigger ring. How do we make a bigger frickin' ring? I don't know. Damn. Switch out the ring on the pad. Well, this is a 5-meter ring, and that's supporting a 375 booster. There's no bigger ring than 5 meter. So how the frick would I make the bigger launch vehicle? We tested the hold down points with a much larger mass like MLV. These hold down points have been tested, yes. HLV should be the same outcome. Let's go here. Let's go here real quick. I want to see something. Let me just throw together an HLV concept here just to see what happens. I'm just wondering what this is going to look like. $5,900 Delta V. 5,900 Delta V in vacuum. That's way too much. Alright, get rid of that. $3.13. And we said that our expectation was like 100 tons, right? We're really looking for 100 tons here. Anything here that's close to 100? Those two pieces of junk are 50, so let's put that there. Put that there. Close the fuel out. And then add like another 10 to 20 tons for the fairing and all the other parts that we're gonna need. That's 1.21 TWR at 1070. Ugh. Okay. $18.05 at 0.91. That's cool, Panta. $1.12 TWR. Okay. Let me go into the full stack prototype. What are the numbers? So 1170 or 1779 at 1.12. What's the? We have 1.0 TWR at 2500. Okay. Okay. Not bad. Not bad. Now this doesn't have the RCS on it or anything, but that's okay. That's not that big of a deal. All right, HLV concept right here. And how much are those? Those are 50.6. So we have we have 120 tons worth of payload and fairing and whatever up there. And that's giving me 1779 at 1.12 with 5 skipper engines. And what was that thing one more time? Our TWR was in line because it was 1.01 on the other rocket, but 2,500 meters a second Delta V. Okay. Fortunately, Delta V numbers, the Delta V requirements scale pretty well. It's just you got to get the TWR right. We're a little short on Delta V. Okay. Huh. 1.54 at 1730. I actually think that would be enough. As long as we nail that TWR, 5 engines actually should be more or less what we're looking for. The reason why is because I noticed that the MLV has an extra, routinely with 18 tons going up into space, it routinely has about 1,000 delta V left over, and it has 2,500. So that is 2,500 at 1.0. 1779, right? Make sure that fuel is locked out. 1779 at 1.12 gives us higher TWR. The delta V margins are going to be a little bit crappier. Rhinos. Yeah, they're nice engines. The other one is 2,500 and it has about 1,000 delta V left over. That means the maximum is about 1,500, 1,700. Okay, let's just play off the notion that that might work. Okay, I'm interested to see if I take like 10 tons off of there. It's 1,900. Okay, cool. Okay. No, just temporarily, I'm gonna put a decoupler here. Just or the camera will break. You know, that works too. Hey, Play the Planet, 32-month resub. Thank you. What's going on, buddy? Get rid of that, take that, move that down there, and just pretend there's going to be fairings and interstages and stuff and all the stuff to make this look nice and pretty. Okay, cool. Sweet. Thanks for coming out. All right, so first stage, what does that look like? I hate these stringers and raceway things that they put on the side. So how about we do okay, something like that. Now skippers, where is that gonna get us? .66. Oh. .22. That's how many of those we need, huh? 1.35, 1.06. Damn. Yeah, how would I fit all that in there? There's really no good propulsion here that's going to fit. Everything is going to have a flare out at the bottom. To some extent, and I'm not too happy about that. Nope. That's nowhere near enough. Seven mainsails would do it though. 1.17, 1.12. That would do it. But if we were gonna do that, then here, let me screw with something here. Okay. Can I? No? Alright. Yay, there we go. .05 at 1700. Are you okay with overclocking? Yeah, sure. I wouldn't mind it. Someone, yeah, don't bother me. Six tons, 5 tons, 1.05, 1.18. And keep in mind, guys, that's with 100 tons of payload. Yeah. If we could just get rid of that stupid ring. If I could just get rid of that, then it'd be freaking money. 310 specific impulse, though. So what? Who cares? I don't give a frick. As long as the Delta V numbers are good. Remember, I need TWR, Tinkelberg. I need thrust to weight. Thrust to weight so we can boost the first stage back and get the AP above 70, right? And then switch back to the second stage and have it circularized before the Kraken eats the first stage, right? That's the kind of stuff I need to figure out. I mean, this thing is going to be an absolute chonker of a vehicle if we decide to make it. Also, going back to the launch ring discussion for a second, would you be okay with editing a fairing in the craft file to remove a section in order to make the launch ring, or do you want us to do that? Yeah, I don't want to do that. I'm not doing that. Yeah. Awesome. This is actually a pretty sweet little launch vehicle. This isn't bad for 100 tons, dude. It's got 100 tons, or 120 tons of junk up here. These two ore tanks are taking into account, like, fairings, probe cores, anything like that, and that's probably a nasty overestimation. In reality, it's probably, the numbers are probably going to be more like this. And what we had there was really, really good. This is a really nice little vehicle here. My only problem is the bottom. The bottom might be a little bit difficult to get this integrated correctly. Because the engines need... I hate clustering engines super close to each other. They don't do that in real life. Engines need to be a little bit of a distance away from each other so they don't overheat each other's nozzles. That really does depend on the engine, though, to be honest with you. Raptors clearly don't give a frick about that. Bottom first stage tank cone shape. Bottom first stage tank cone shape. There's no cone shaped tank that goes above 5 meters, Chief. That's actually really nice. I like this. This is good. This is a good design. $13.79, $12.83. Let me just... Can I see it with these just one more time? I think the reason why I didn't go with this is because they didn't cluster very well, but... That's 1.07 TWR. 2,500. What happens if I took this off? 1.09. Yeah, it didn't really change much. But these could be clustered a lot better. We could get a slicker profile here with that. That definitely could work. 1.07. See, we can't cluster these like that. That doesn't work. That doesn't work that way. Right? That isn't going to work like the... Hey. Hey! Get back here. There we go. Not bad. This could work. It's actually a pretty sweet little design. Well, it ain't little. What are the numbers if we do that? It's 1.01 TWR, and that switches it to 1.03. So what if I went with an 8-engine cluster and we went 9 engines in total, 1.29, 1.05. What about vectors? What about them, Penta? They're heavier and they don't make as much thrust as these. Actually, they're lighter, but they don't make as much thrust. I hate using shuttle engines or anything but shuttles, but honestly, it's not a bad idea. The reason why it's not a bad idea is because they're super compact, because they don't have any of their turbine machinery modeled, because they were designed for the shuttle. 0.87. And if we went back to the 4-core design, like that, 1.01. Yeah, who would do such a thing, Eugenes, right? If this is supposed to be an Ares-style rocket, then using SSMEs isn't too cursed. Yeah, but those mainsails were just getting such better performance. We're getting so much better performance with those things, and they're not nearly as expensive. Oh, they are. They're freaking super expensive. Those are only 8,000. Oh, screw that. I'm gonna use Mastodons. Mastodon engines are better anyway. But these aren't really that compact, though. That's the problem. Interesting. Interesting. Not bad. Guys, I had an interesting thought, okay? And you guys... Yeah. Interesting. Come on, man. Fucking COVID. My thought is... No, I don't... I mean, this is good. I can make this. This will work. We're going to have some problems with hold downs because we need so many engines down at the bottom. These numbers are good, though. Their numbers are really nice. Actually, just... Just pretend those are M1s and call it a day. 0.95 TWR, though. Ah, 0.92. It's so damn close to being right. These numbers are so close. It's so close to being correct. What is it in the 4-tank configuration? 1.07. Weird idea, but if you put them in an outer ring and inner ring, you can fit 11 SSMEs on a 5-meter stage. Yeah. Yeah, no. Did they redo that? I don't remember that looking like that. Yeah, they must have. They gave that an art pass. And how much tonnage is that? 80, yeah, 81. Yeah, it's 81 tons. Okay. Interesting. Interesting. Okay. Brain break for fresh pots. Yeah. I'm just thinking about some things, guys. I'm trying to... 1.07 off the pad is no good. But... if... I mean, this is with 100 tons of payload. What are the odds we actually launching 100 tons? I mean, we could launch with 100 tons. We just showed we could do it, but those more likely are the numbers that we're going to encounter. 1.13, 1.15, which actually is not too incredibly bad. .07 off the pad is Apollo liftoff TWR. Yeah, Rocket Guy, it's not too bad. You know, if we gave these, if we punched these out and gave them a slight overclock, we could be in the ballpark, dude. That really wouldn't be too incredibly bad. Let me see what we're dealing with here. No, that's too much. Yeah, see, something like in there. Copy that, put that down here like this. Punch them out there, and then get rid of the cow controller. You don't necessarily need the OC controller like that. All right, and I'm gonna do a dumb here, and if you will humor me. Hi, I'm Kerbal. I know you're building inside of this hangar. Would you like me to put the part outside of the hangar? No, I wouldn't, Kerbal. Can you not do that, please? Oh. Well, I'm pretty sure you want it outside, so I'm just going to leave it there just in case you need it. Oh, okay, cool. Yeah, I know what I just did. I hit the launch button in the SPH. Gotta give those Kerbals with the trucks jobs. Okay, that's fair. Rocket Guy, part of me is thinking like Falcon 9. Falcon 9 was supposed to lead to like Falcon 10, and there was Falcon 1, Falcon 5, Falcon 9, right? And they just said, screw it. Go with the heaviest duty lift vehicle and just use that and then make, you know, And then there was Falcon Heavy, etc., right? Like, yeah, 1.23. 1.23 with those things have, when those things have 140% rated. You know, part of me is like, maybe just build the workhorse and be done with it. So we only need one rocket. It simplifies a lot of things. But see, like, then again, man, if I'm only doing one rocket, we're only building one rocket. I don't know. Why is it wobbly? It's because I slid it down the runway. You know, why don't we... Why don't we just use one? See, part of me is like, MLV can do 18 tons into low Kerbin orbit. That should be good enough to do some pretty good architecture with landers, vehicles, stuff like that. It should be pretty good. Like, I should be able to do stuff like that. And with the quick turnarounds, that means we could get 3 or 4 launches done in one stream and then go to the moon and then come back. Like, that's not... You know, in a 6-hour stream, we could get a lot done because of the quick turnarounds, right? As long as I have the payload all made. But then again, we could also do one launch. If we keep going with the HLV with these overclocked engines, we could go with one launch, and one launch could basically do everything. But also at the same time, the HLV has overclocked engines. If I overclock the MLV's engines, then the payload capacity will go up exponentially. Because right now, MLV is getting into space with 1,000 Delta V left over in that first stage. We increase first stage TWR, yeah, our payload capacity would go up really high. And then we're open up to stretching the vehicle, etc., etc. What's the cost difference between the LV? It doesn't really matter, JDI, because they're reusable, you know? There's still a problem with supply and demand. Do you have the necessary cadence, destinations, payload, and mass to warrant such a large and expensive system? I mean, in mission mode, it might be better to just use the MLV for a while. And I know that that's what Gaw was suggesting. A viewer in chat suggested that already, dude. But... Gaw was suggesting that, and I was like, that's not a good idea, because if we say, oh, you know, we'll use MLV and we'll figure out HLV later, you know, like, is HLV ever going to get made? Will the heavy launch vehicle ever get put together? Could you get there with 18-ton payload capacity? Sure. You need to design everything now to ensure interfacing, but you don't need to build everything now until you need to. Look at Saturn. Yeah, that's what Gaw was actually saying. He actually said that same thing. Yes, it'll get built in here. Here's why. MLV would great be the initial expansion, but the further and further we go, the more 18 tons will limit us. All we have to do... Why don't I just make a bigger fairing? All you have to do now is HLVs get the dual rocket pad set up with ideas and mounting basically. Yeah, that's true. That's true. That's true. Last, please. And yes, HLV will get built because it will simplify life later. Now it will complicate life. Yeah, okay. HLV with an added stage. What? What about it? You confused me. I don't know what the context of that statement is, Chief. Sorry, I'm talking about like 30 different things, dude. First stage heavy launch vehicle with a different second stage. What problem does that solve? Yeah, JDI. Well, this is what NASA does. This is what SpaceX does. They sit there and they think for a good long while about what they want to build, and then they build it. Building it is the easy part. Have you read Lori Garver's book yet? I don't like Lori Garver, Eucnus. Yeah, I don't like it. I don't like how she views spaceflight. She's absolutely right in championing commercial, but she sacked our national space program and pawned it off to corporations in the name of commercialization. I have a real big problem with that. I'm not going to read her book. I'm not really interested in what she has to say. And don't get me wrong, it's not personal or anything. I just very, very wholly disagree. If you're only using one vehicle, would you do something like direct where you upgrade, add things to get more out of it? Yeah, I don't know, maybe. I mean, you just don't get me wrong. The championing commercial was a good idea. That's a good call. That's a good idea. And commercializing low Earth orbit is also a good idea. Like bringing people like Elon in, bringing things like SpaceX in, absolutely. Absolutely a great idea. Long story short, that led to Starship development, etc., etc. But at the same time, if that means sacking our national space program, i.e. getting rid of Constellation and setting NASA's human spaceflight back pretty much two decades. Yeah, I'd say 10 years at the best. If that means sacking our national space program, I don't know if that's the wisest decision. But you got to understand the circumstances in which that whole situation happened. They said that we came up with commercialization. Commercialization is the way that NASA needs to go. Commercialization is what Constellation was already doing. Constellation had always planned to commercialize low Earth orbit and hand it over to corporations when NASA decided to go back to the moon. So that was already pretty much happening. You got to understand that a little department in the Constellation program called Commercial Orbital Transport Services was started during the Constellation program. SpaceX won the contract that gave us Falcon 9. They won that contract in 2008. Mid-2008. Lori Garver wasn't even working at NASA at the time. So who really championed commercial spaceflight? The idea that we champion commercial, I would always argue that that's a fluke. That's a look over here while we gut NASA. Look at this good thing. While we gut NASA and literally put thousands of people out of work just because they go too slow or whatever the hell that means. I'm not too incredibly happy about that, and neither are not a lot of people are. But don't get me wrong, I can't sit here and say that was a stupid idea, right? Because SpaceX is so damn successful, right? We sacked our national space program for commercialization. Only time will tell if that was worth it. and then struggle to bring back people for SLS for a few years. Once again, NASA's Human Spaceflight Division was set back decades because of that decision. I'm really interested to see if it's worth it. Now, I know what people are going to say. You know, people are going to say, oh, well, yeah, we get stuff like Starship, so NASA can just use SpaceX. Do you want NASA and NASA's scientific advancements to be beholden to a corporation to launch? Does that sound smart to you? Think about it. One corporation controlling everything that NASA launches into space. Now all those people that say, oh, NASA should just launch everything on SpaceX, that doesn't seem like such a smart idea now, does it? And don't get me wrong, I don't like talking bad about SpaceX. I love SpaceX. I think what they're doing is absolutely 100% right. What I'm saying is, if we really want to be sustainable and serious about going into space, NASA should have something like Constellation as well. A full, robust national space program to supplement commercial. They should work together. Very similar to how SLS and Starship are going to end up working together. But I also don't like the fact that NASA is beholden to a company operating a spacecraft to get to the surface of the moon. I really don't think that's a good idea. I don't think that's very sustainable in the long run. Do you? NASA has to use Starship to get to the surface. Why do you think NASA's focusing so hard on bringing 2 landers into the fold? Because they don't like that idea either. They don't like having one lander. I mean, one lander that can get them to the surface and being beholden to basically SpaceX to launch anything to get to the surface of their moon. That's not very sustainable. I don't care what anybody says. That's not a sustainable space program. That's putting all your eggs in one basket. That's no more sustainable than building your own in-house lander. Like Apollo. Someone could easily come along and just say, no, you're not doing that. Right? Not very sustainable. The only real good way for sustainability in space is competition between corporate space programs and government space programs. They should be working with each other. And that government set price is a good way for corporations to compete. Just like how the Fed would set an interest rate. If NASA has a price for a launch, corporations say they do it better to lower the price. And it works reactionary. That creates a much more sustainable economy in space, using the government space program as a datum for pricing. And before you say, EJ, that sounds pretty dumb. SpaceX already did that. Elon looked at the space shuttle and said, that's too expensive, I can do it better. How do we know what expensive is if we didn't have the space shuttle as an indicator for what was a very inexpensive way to move things into space? Just something to consider, I suppose. I agree, but NASA needs more freedom. If NASA could build spacecraft of their choice, I doubt they would build SLS. I mean... You don't have to talk about sustainability. If you launch 8 SLS over the next 10 years, that's the bottleneck, not commercial. Yeah, Galaxy, that's not what I'm talking about. But that's fine. Hey, I appreciate the dissenting opinion. I agree with you completely if it didn't seem like Constellation SLS were just ways of funneling money into contracting companies. Oh, man, Eucnus, what the hell are you reading? You boys need a history lesson. Jeez. I'll explain more in a second, and I'm not saying you're wrong, I'm not saying anything like that, but clearly there's not a lot of people here that understand why SLS is the way that it is. I'll explain that in a moment. I agree, but NASA needs more freedom. Okay, Rocket Guy. In regards to KSP, I say it is good to do it all right now. MLV and HLV. Complete mock-up for test interfaces, but only use the 2 when it makes sense, like finding the right tool in the toolbox. You wouldn't use a hammer to take a nut off the carb, would you? Yeah, hopefully not. I've been reading your book. Yeah, I know.